Okay, am I audible to everyone? I think Honorable Chairman Sir has already joined. Shri C.H. Venugopal Reddy Sir. Sir, are you able to hear me?
Yeah, I'm very much here.
Yes,
I'm
sir.
able to
Yes,
hear you.
sir. Yeah, yes, sir. We are also able to hear you. Please be there, sir. I think now we can start. We are having a little bit of mic issue with Kumaraswamy, sir. Shubhadeep, sir. Shubhadeep, sir,
Yes,
are you
ma'am.
there? Yeah, you can
Yes, ma'am.
start the program. Chairman, sir, will be addressing the guest. Okay, sir.
Okay. Okay, ma'am.
Okay, just a minute, 2 minutes. Please wait. Let me once try with Kumaraswamy, sir. Let me try.
Now I am unmuted.
Yes, sir. Kumar Swami, sir. Now you're audible, sir. Okay.
Uh,
I think we should start now. Already the guests have arrived and we are keeping them waiting. So, Shubhodip, sir, please start. Go ahead. Shubhodip, sir. Yeah,
Good
please start.
evening to all the honorable guests, respected dignitaries, participants from all over the country, and my dear colleagues for attending here today in the 6 days online AICT Atal FDP titled as AI and Quantum Computing, the Future of Intelligent Systems. Myself, Shubhadeep Goswami, Assistant Professor in the Department of Electrical and Electronics Engineering of Bharat Institute of Engineering and Technology, Hyderabad, the coordinator of this Atal FDP, and it is my honor and privilege to extend this warm welcome to all of you into this faculty development program organized by Bharat Institute of Engineering and Technology. This program, under the Atal initiative, presents a great opportunity for professional development, and we are so happy to have such a distinguished gathering of educators, experts, and thought leaders among us for this enriching experience. This faculty development program aims to enhance our faculty members with the latest knowledge and skills that they would require in all these emerging fields of technology. The next few days would allow us to explore new innovative pedagogical approaches, leading edge research, and the best practices to enhance the quality of education that we are imparting to our students. Now let us begin initially with the Saraswati Vandana in order to seek the blessings of Goddess Saraswati, who is the abode of knowledge and wisdom.
हे शारदे मां हे शारदे मां अज्ञानता से हमें तार दे मां हे शारदे मां हे शारदे मां अज्ञानता से हमें तार दे मां तू स्वर की देवी है संगीत तुझसे हर शब्द तेरा है हर गीत तुझसे तू स्वर की देवी है संगीत तुझसे हर शब्द तेरा है हर गीत तुझसे हम हैं अकेले हम हैं अधूरे तेरी शरण हम हमें प्यार दे मां हे शारदे मां हे शारदे मां अज्ञानता से हमें तार दे मां
Next, moving on in the initiation of this inaugural session of this FDP, we are grateful to Professor G. Kumaraswamy Rao, the director of Bharat Institute of Engineering and Technology and former director of DRDL, who has been instrumental in taking this institute forward in shaping its vision. He is a highly experienced scientist from R&D who have headed national reputed laboratories. He was the former director in the Ministry of Defense. So let's welcome our respected and reverend director, sir, for his inspirational speech.
Okay. Thank you very much. Good evening to the chief guest, Professor Anil Sahasrabudhe, guest of honor, Sri Sudhir Kumar ji, and Sri C.H. Venugopal Reddy, our chairman Garu, dignitaries, participants, and organizers on the occasion of inaugural session of ATAL FDP on AI and quantum computer, the future of intelligent systems. This FDP is sponsored by AICTE New Delhi and being organized by Dr. Papiatat and her team in Department of Electronics and Communications of Bharat Institute of Engineering and Technology, Ibrahim Patnam. On behalf of BIT, as a professor, I am proud and honored to extend a very warm welcome to Professor Dr. Anil Sahasrabudhe and Chairman of NETF, NBA, and NAC, our chief guest today, and Sri Sudhir Kumar ji, Director, Samsung R&D Institute, Bangalore, and Sri C.H. Venugopal Reddy Garu, Honorable Chairman of Bharat Institutions. Professor Dr. Anil Sahasrabudhe is well known as a visionary educationalist in academic circles, which while chairman of AICTE, he has introduced number of radical reforms in academics. He has brought in a cordial interface between academic institutions and industry. His well thought out concept of internship to students in industry benefited the present students. They have become eligible for immediate employment in industry. We are grateful to you, sir, for gracing this occasion. Mrs. Samsung is one of the leading multinational industries in the world. To occupy this prestigious share of Director of R&D Unit is a great achievement. Sri Sudhir Kumar is now the Director of R&D of Samsung. We are grateful to you, sir, for accepting our invitation to this inaugural function. Coming to the bug word AI, this is so popular, even 8 to 9 class students are being taught in their curriculum. Presently, it is the topic discussed everywhere, either it is in academics, or in industry or in defense. Having worked 37 years in DRDO and retired as the director of an electronics warfare lab, I thought I will bring out one or two instances where we have used AI algorithms. Though John McCarthy coined the word AI in 1956, it became popular only since last 10 to 12 years. Several years even before this popularity gained, defense equipment was using the AI concepts, of course, in a different name. Defense scientists brought out a number of concepts like spread spectrum, frequency hopping into communication, and the commercial technology. In a battlefield, it is crucial to know the location of military naval ships. This determines the strategy and tactics to be used in the battle. All the ships are mounted, unfortunately, with the same type of radar, with a particular frequency, pulse width, pulse repetition rate, etc. It is necessary to distinguish each naval ship with an accurate location with their name, ship's name. A technique known as fingerprinting was used with certain algorithms similar to AI algorithms. It involves data fusion and AI type algorithms. As a second example, I would like to bring to your kind notice the recent bombing of Iran military installations by Israeli F-35 bombers. The bombers encounter air defense radars, missile radars, enemy aircrafts in dogfight. The bombers knows the location of air defense systems and enemy aircraft through the friend or foe algorithms, AI algorithms. The jammers used are smart jammers, again controlled by AI algorithms. S-300 and S-400 air defense radars of Russian origin could not shoot down any aircraft due to the operation of jammers and controlled by AI algorithms. Not even a single F-35 aircraft was shot down. The AI algorithms protected the aircrafts. Recently, you are aware that a large number of rockets were fired by adversaries of the Israelis. It was brought out by the news agencies that Iron Dome is a failure. It is a modern EW protective system with number of AI algorithms. Remember, a rocket is not guided. If its cost is X dollars, cost of a guided missile to shoot down a rocket is 30 times of the cost of a rocket. A rocket or a drone carry a very small size bombs. It is not economical to shoot down all the rockets or drones. The damage caused by the rocket at best may damage a building, assuming its ballistic path is good. Whereas a bomber damages almost 1 to 2 square kilometers area. Depending on the ballistic curves, the AI algorithms find out which one a rocket or a projectile is a dangerous one, which may damage the area of civilian area or a military establishment. Only those things, rockets or projectiles are shot down. The rest of the things are allowed to go. That is the reason why people has a misnomer that Iron Dome has allowed and the AI algorithms has failed. Fortunately, AI has entered in a large scale into the defense. AI is being tested to develop the low probability interference radar detection, autonomous vehicles, pattern recognitions, and hyper personalization, etc. The advantage of AI in defense is it can examine vast data, merge those data, take quick decisions, predict the maintenance of military hardware, etc. Before concluding, I have the honor and the privilege to once again express my institution's greatness to chief guest and the guest of honor. Thank you for giving me this opportunity to speak before so many dignitaries. Thank you very much.
Thank you, sir, for your inspirational speech and your blissful blessings. Next, moving on in the inaugural session, a very special mention to Dr. Papia Datta, convener of this FDP, as well as associate professor in the Department of Electronics and Communication Engineering, for her untiring effort in organizing this program and bringing into this excellent lineup of speakers and experts. Let's welcome Dr. Papia for her speech regarding the FDP.
Thank you, sir. Good evening to our respected dignitaries. Honorable Chief Guest, Dr. Anil Sahasrabuddhe, sir. Guest of Honor, Mr. Sudhir Hunde, sir. Honorable Chairman of Bharat Institution, Sri C.H. Venugopal Reddy, sir. Professor G. Kumaraswamy Rao, sir, Director BIET, and participants throughout the country. First and foremost, I would like to extend a warm welcome and express my heartfelt gratitude to all our distinguished guests for joining us today. Despite of your busy schedule, sir, you have graciously blessed us with your presence on this important occasion and hence we are truly honored. I'm delighted to be here to present the details of the FDP. Artificial intelligence and quantum computing stands at the intersection of two of the most transformative fields in modern technology. These two fields are not only pushing the boundaries of what is possible today, but are also laying the foundation for the intelligent system for tomorrow. This faculty development program will focus on AI and quantum computing, exploring how they can empower educators, researchers, and professionals to stay ahead of the curve in the next wave of technological innovations. We are pleased to share that we have received an overwhelming response from faculties across the country. And after careful selection, we have shortlisted 336 participants for this program. A special thanks to AICTE ATAL Academy for providing us the opportunity to organize this prestigious program. We are also fortunate to have with us a distinguished pool of resource person who will guide us through this journey of knowledge. We are honored to have Mr. Rohin Koduri, Scientist F from DRDL, Mr. Vidyasagar Tejamurtala, Principal Architect from Zelis Healthcare, Mr. Sitaram Tarepalli, Vice President from ML Engineering, Dr. Abhinav Kumar, Professor from IIT Hyderabad, Dr. Debashis Das, Associate Professor from IIT Jodhpur, Dr. Suman Dev, Associate Professor from NIT Agartala, and Dr. Anish Chivukala, Assistant Professor from BITS Pilani, Hyderabad, as our esteemed resource persons for this FDP. In addition, we are privileged to have two international resource persons with us, Dr. Siva Kumar Subramaniam, Technical and Project Manager, IIoT SME from Malaysia, and Dr. Yogan Jayakumar, Associate Professor from University Technical, Malaysia. Their global perspective will add tremendous value to this program. As we embark on this faculty development program on AI and quantum computing, which continues from today until 14 December, it will play a vital role in preparing us for the future of intelligent system. But by providing the tools, knowledge, and skills necessary to harness the potential of these technologies, we are not only advancing our own understanding, but also ensuring that the next generation of researchers, innovators, and professionals will be well equipped to tackle the challenges of tomorrow. As we continue to explore the convergence of AI and quantum computing, we must remain steadfast in our commitment in innovation, collaboration, and addressing the ethical implications that these powerful technologies bring. The future is undoubtedly exciting, and with programs like this, we have the opportunity to contribute significantly to shaping the intelligent systems of tomorrow. Thank you all for your presence and participation. I hope you enjoy the next 6 days of learning, exploration, and growth. Thank you.
Thank you, ma'am, for your wonderful speech. Next, moving on, we owe our gratitude to Sri C.H. Venugopal Reddy, sir, the Honorable Chairman of Bharat Institute of Engineering and Technology, for his consistent guidance and support, which made this event possible. He is an eminent educationist with a social conscience and commitment. He is the secretary and correspondent of the Chinta Reddy Madhusudan Reddy Educational Society, established in the year 1991. So now let's welcome our chairman, sir, for his motivational and inspirational speech.
Very good evening, all the participants and dignitaries, and my dear participants. It is indeed a great privilege to me to be with you in this. Let me express my gratitude towards Professor Anil Sahasrabudhe for accepting this our invitation to be the chief guest for this inaugural function. Similarly, I must be thankful to Sudhir Kumarji for accepting to be the guest of honor for today's inaugural session. I think, and also let me express my gratitude, thanks toward that AICT also. This is the need of the hour. In fact, uh, to evolve, to mold, our teachers better way, better manner. Certainly, this kind of FDPs are much useful. Certainly, it is great opportunity to all the faculty members. We wish all the faculty members must make use of this opportunity. Thank you once again for providing me this opportunity. And also let me congratulate the organizer and also the lady who who have taken all the pain, who have taken all the initiative. That is Dr. Papi Datta Madam for taking this kind of initiative. Let me appreciate her on this occasion. Thank you all the organizers. Thank you once again. Namaste. Thank you very much.
Thank you, sir, for your inspiration and motivation. Next, moving on, I would take this opportunity to extend my warm welcome to our guest of honor, Mr. Sudhir Kumar Hundi, Director of Samsung R&D Institute, Bangalore, who graces this event and whose presence makes a difference closer to industry. But before inviting him for his great speech, let us know about him and his profile. Mr. Sudhir Hundi, based in Bangalore, is currently a director at Samsung R&D Institute. He brings experience from previous roles at Tata Consultancy Services. He holds a 2021 Thought Leadership Program in Organizational Leadership from Indian Institute of Management, Bangalore. Currently, he is the leading Network One OEM team developing for 2G/4G/5G, 4G/5G core, NR and LTE, small cell or IAU products. He has rich experience in leading teams, designing and developing network products across the generations. He is also a domain expert in network data plane across access and core network products. He is a lead benchmarking the designing and the development of fast path on network processes for various also the virtualization and containerization of access and core network, enabling deployments on cloud infra. He is also associated with the design and development of multi-edge access computing nodes, lead cross-functional teams across the access and core networks, system software, call processing, and OAM. So now let's welcome Mr. Sudhir Hundi sir for his motivational speech.
Thank you all. It's a privilege and an honor to be on the same page of the dais with Professor Anil Sahasrabudhe. And thank you, sir. And I would like to thank Dr. Papia for making an invitation to grace this occasion and address the gathering. And definitely I'm very thankful to Bharat Institute's chairman, Venugopal G. Definitely, it's really nice that your institute has tied up for won the award for conducting this FDP. It's really nice that it is being done. And as you said, it's really important to do this, to reskill and think about what we have to do for our next generations to come. And definitely, I would like to thank Dr. Venugopal Garu. You gave wonderful examples how you have championed the use of AI and some of our defense, what would I say, in our defense manufacturing processes or like its use. So today, I think AI has become ubiquitous with everything, right from finance, commerce, science, technology, right everywhere. I think application-wise, once ChatGPT was launched, I think every layman, every student started widely using it, right? So it becomes inevitable that all the disciplines should definitely become comfortable, continuously learn what it brings us for us in the future or in the current. Like, there's no more future. It is here. So it's really important to adapting and building our students in the ecosystems towards this for its use. Some points which I definitely wanted to share with all of you. Learning is continuous. I have joined some courses now to skill up myself in AI, just being used networks and telecommunications predominantly for all optimizations, deployments, everywhere. So definitely it is very important to learn and to teach this. At the same time, some really important pointers which I have observed. Every student that we do have multidisciplinary engineers, freshmen who are joining us from college. Almost many of them are skilled up in AI, applicative AI, learning about things. For example, a CS engineer learning, doing it, definitely I do understand, but non-CS, non-students, I think for learning purpose and for job market purpose, it has become essential that everybody learns AI. One marked difference that I can see is uh, learning AI for the sake of learning AI is not good. Definitely, as students, as the ecosystem, right, you definitely need to look up for example, an electronics engineer or like a civil engineer, we have seen that they are foregoing their core sciences. It's really important to invest time and effort in learning their core sciences first and seeing how to adapt and invest AI into their curriculum so that it can solve large problems for our nation. So that is really fundamental. As much as fundamental to AI, I think every discipline it is whether it is finance now, whether it is economics, whether it is civil engineering, whether it is electronics, it can be adapted everywhere. That's the best part of AI, right? Whether it's automation, it can be done everywhere. So it's really important to first deep dive and learn the subjects for which they are enrolled for really well and see how they can apply in that domain instead of switching domains. That's one point I would definitely like to share. As faculties, I think this is one drive I would request all of you to invest a lot of effort in adapting them to their core knowledge and applying AI there. Coming to the second point, I think Dr. Papia mentioned about it is ethical AI. I think data is the new oil, right? As the saying goes. So we capture data, we process data. There is open source data, there is open data, there is a lot of data. It is on which this foundation models are built. So ethical AI must be taught right from college, and faculties, as faculties, definitely should invest time and effort in educating our engineers and students about the ethical use of AI, whether it is data, whether it is application, or like how it impacts the end user or the consumer, right? Definitely using it. There are a lot of frameworks. All nations are building frameworks for ethical use of AI, right from capture of data and storing of data. So it's really important for our generation to understand how this data is used, getting valid consent, getting valid use. All the framework should understand right from the college time is what I believe. That's the second note which I wanted to share. And lastly, I think many of the foundational models that we are currently using is predominantly from university and what would I say, public-private partnership, big corporates, big governments. They have played a role in coming up with the large foundation models that are predominantly used today, GPT-4 or like Llama or any of this. Definitely, I think India is a very large country and we have a lot of applications and we have a large population, definitely. So I believe that we should build our own foundation model. We should have India-based or India data-based foundational model, a large model which can be adapted to the industry. And I think Indian government a few months back instituted the India AI Forum. I think there is from the Ministry of Electronics and Information Technology, almost 10,000 crores is being set up to build our own large scale model. So foundational model. So it's really important. And the idea is that they want to collaborate with the industry as well as with the academia, researchers, the best minds in our country. So this will be a very good opportunity for all the faculty here to contribute towards this effort in building a foundational model for India, by India, and for India. So this will help us to have the edge. I think AI is going to rule, and it's going to be the backbone of the country. So it's very good to have our own foundational model. So I look towards some efforts from the academia and the researchers here to work towards this to build our foundation model. So these were some of the points which I wanted to share with all of you. So thank you for giving me time to share my thoughts, and thanks again for the invite. Thank you.
Thank you, sir, for your
Yeah.
motivational speech. Next, moving on to the inaugural session, I would like to extend a special welcome to our chief guest, Dr. Anil Sahasrabudhe, the chairman of NETF, NBA, and NAC. We are honored to have you, sir, with us today, and we look forward to your insightful address. But before that, I would like to invite Dr. Papia Datta, convener of this FDP, to say something about our chief guest, Dr. Sahasrabudhe.
Thank you, sir. Dr. Anil Sahasrabudhe, sir, is a distinguished academician, technocrat, and visionary leader in the field of higher education in India. He is best known for his role as the chairman of the AICTE, where he has been the forefront of steering educational reforms and fostering innovation in India's technical education landscape. Presently, Sir is the chairman, National Education Technology Forum, NETF, NAC, and NBA. Dr. Sahasrabudhe, sir, holds a deep academic foundation, having earned a PhD in mechanical engineering. Over the years, he has contributed significantly to academia, both in terms of leadership and innovation, while shaping the educational framework for India's engineering and technical disciplines. Prior to his current role, he has served in various academic and administrative capacities, including being the director of IIT Guwahati, one of the India's premier institutions. His leadership at IIT Guwahati helped the institution enhance its global presence and educational standards. As chairman of AICT, Dr. Sahasrabudhe sir has been instrumental in advancing initiatives to improve the quality of technical education across India. His efforts have included the promotion of industry academia partnerships, fostering skill based learning, and implementing new accreditation standards. Dr. Sahasrabudhe sir has been a vocal advocate for updating curricula to meet the demands of rapidly evolving industries, particularly in areas such as artificial intelligence, data science, and robotics. Under his leadership, AICT has pushed for major reforms aimed at improving access, equity, and inclusion within technical education. He has played a crucial role in expanding opportunities for students, including initiatives to support underprivileged communities and empowering women in STEM fields. Dr. Anil Sahasrabudhe sir remains a leading figure in Indian higher education with a commitment to shaping the next generation of leaders, engineers, and innovators. His work continues to inspire and influence the education policy landscape in India. With this, I now invite Dr. Anil Sahasrabudhe sir for his presidential address.
Namaskar. Good evening to all of you. Dr. Papia Datta, it was too long a introduction. Anyway, Mr. Sudhir Kumar, Director of R&D in Samsung. Mr. Venugopal Reddy, Chairman of Bharat Institute of Engineering and Technology. Professor Kumar Swami Rao, Director of BIET. Faculty members, students of BIET, other delegates, participants for attending this AICT sponsored online ATAL program of 6 days duration, which the national level ATAL FDP on artificial intelligence and quantum computing, the future of intelligent systems. My predecessor speakers, be it Dr. Venugopal Reddy, Papia Datta herself, Professor Kumar Swami Rao, and Mr. Sudhir Kumar have already spoken about importance of AI and quantum computing in today's world. So it is not just the future, but it is already the present. Well, AI is going to be here. It is to stay. So we must address our entire national education policy from the perspective of what are the needs of the industry and how we take it forward. And therefore, right from school education, there has been a course of AI introduced by the CBSE. That means the future generation is being created right from our school education. As far as higher education is concerned, including the technical education, which is AICTE driven, there have been enough opportunities provided for the colleges to have electives on AI. Started with that, but subsequently, since the demand was growing, AICTE has announced a minor degree program in the artificial intelligence, machine learning, robotics, drone technology, and so on and so forth, including quantum computing. That means, on one side, whether it is a discipline of civil engineering, mechanical engineering, electrical, chemical, metallurgy, any one of them, as rightly pointed out by Mr. Sudhir Kumar, AI is going to be an application which is going to be there in all disciplines of engineering, not only engineering, but in fact in healthcare, in finance, in our dealing with transportation system, you name it, and there is going to be AI. AI is nothing but, as we know, artificial intelligence. So all the data that is collected over several decades, which is now available on our databases in our different types of systems which are there in the cloud, one can extract right kind of information which will give us solution for the future in different domains of knowledge, domains of application. And added to it, when quantum is added, quantum computing, there is another new area which is going to give us a challenging time or frightening time, is that of security. So far, security was much easier, but in quantum, maybe security has to have a different dimension altogether. And therefore, AI and computing, which is especially quantum computing, the future intelligence systems are going to be more diverse, more capable, and the nature of applications could vary tremendously, be it then in the form of education, that is personalized learning on one side, to applications in agriculture. What type of crop is to be grown in which season, what kind of rainfall is likely to happen, to how the produce that is produced is to be done marketing. So the entire system of transportation will also come into play. And therefore, whether it is, as I said, education, healthcare, agriculture, or the human life itself is going to be greatly affected. And given to it, not only cyber security, but also the security in terms of missiles being dropped from different places, drones coming in large swarm and then attacking. I think a lot of intelligence, data analytics is going to play in order to create safe planet, safe systems, safe countries. And that is where smart learning, machine learning, deep learning is going to play a very, very big role. So the future intelligent systems will have quantum as one important thing. Therefore, India has created a quantum mission in order to address the new areas, new challenges that are going to be there, new applications which are to be derived from out of them. A semiconductor mission, because we are heavily dependent on entire electronics import from some of those countries like China, from Taiwan, from US. And therefore, how do we become self-sufficient, Atmanirbhar in even semiconductors? So quantum mission and semiconductor mission are two ideal missions which have been undertaken. Along with that, AI is going to play a big role, as everyone has said. So three centers of excellence of AI, one in agriculture in IIT Ropar, the second one in terms of healthcare and medical systems from two institutions together in Delhi, that is AIMS Delhi and IIT Delhi. And the third one is on sustainable cities, smart cities from IIT Kanpur. So these three are very significant and important AI-driven initiatives of the Government of India. So huge number of automated devices or autonomous cars, vehicles, robotics, all of these are going to have huge applications from both AI and quantum computing. And we cannot fathom today what is going to be the nature of the future of the intelligent systems. They are going to be extremely intelligent, no doubt, but where do we stop them? Will they be completely controlling themselves? These are some of the questions which, in a way, were raised by both Papia as well as by Venugopal Reddy and Sudhir, that the ethical feature of that is important. Therefore, whether it is United Nations, whether it is different countries are regulating both data security, cyber security, and the ethics of this, which is going to play a very, very important role. And these have all connection with our SDG goals, whether we want to achieve access equity in terms of the education, whether it is in terms of good healthcare, how making use of the emerging technologies, our life on the planet is to be not only sustainable, happy, healthy, and create a better world to live in. And that is the philosophy with which we all are working. I'm sure this 6 days online program where experts from different domains are going to speak, all the delegates who are attending this or the participants will get amount of knowledge that is immense, which they can carry forward in their respective colleges and institutions so that our next generation of students are also well prepared. But nevertheless, remember that the learning should never stop. This is only the beginning. You are learning some tips of the iceberg. Many things are to be learned. Today, technology enables you by sitting and at your home through whether it is Swayam courses, whether it is Coursera or the MIT edX program or the YouTube, many new things you can learn and continue to learn. Only then you can remain successful. And to empower, whether it is the students or the faculty members, what Government of India has created called as APAR ID, which is exactly similar to Aadhaar ID, which is an automated permanent academic account registry where students can get registered and then create an academic bank of credit of their own, and all learning, whether formal or informal, can be deposited in this account, which can become your lifetime CV, building of your biodata, right from school education till the retirement and beyond. So make use of all the facilitation that is being provided by the Government of India, empower yourself and make yourself happy and make the nation happy. Thank you very much. Namaskar.
Thank you, sir, for your motivational speech. Now, moving on to the end of this inaugural session, I would like to introduce Dr. Satyabrata Sinha, Assistant Professor of Electronics and Communication Engineering Department, who is also the co-convener of this FDP, for his technical contribution to organize this event. Let's welcome him for his vote of thanks.
Good evening to all the dignitaries, esteemed guests, and participants gathered here today. I myself, Satyabrata Sinha, co-convener of this FDP. It is my privilege and honor to propose the vote of thanks at the conclusion of this inaugural session of the 6 days online FDP under ATAL initiative organized by Department of ECE, Bharat Institute of Engineering Technology. Today's session has marked the perfect beginning of what we hope will be transformative learning experience for over the next 6 days. First and foremost, I extend my heartfelt gratitude to our chief guest, Dr. Anil Sahasrabuddhe, Chairman of NATF, NB and NET, for gracing this occasion with your presence. Your participation in this event fills us with optimism and inspires us to make this FDP a great success. I would also like to express my deep appreciation to our guest of honor, Mr. Sudhir Kumar Hundi, Director of Samsung R&D Institute, Bangalore. Your encouraging words and support have motivated us as we begin this journey. We are immensely grateful to Sri Chintagopal Venugopal Reddy sir, Honorable Chairman of BIET, whose unwavering support and guidance have been cornerstone of making this event a reality. Sir, your vision continues to drive us towards excellence. A special note of thanks to Professor G. Komaraswamy Rao sir, Director BIET, former Director and OS of DLRL, Ministry of Defense, for his leadership and strategic direction in shaping this institution and program like this one. I would also like to extend my sincere thanks to Mr. Subhadeep Goswami, Assistant Professor in the Department of EEE, BIET, for his invaluable support as the technical assistant for this FDP. Your dedication and assistance have been instrumental in ensuring the smooth preparation for this event. This event would not have been possible without meticulous planning and untiring efforts of our convener, Dr. Papya Datta, Associate Professor in the Department of ECE, BIET. Ma'am, your dedication and organizational skills have ensured the seamless initiation of this program. To all the esteemed speakers and experts who have joined us for this FDP, thank you for committing your time and knowledge to this program. We eagerly look forward to your sessions over the coming days. A heartfelt thanks to all the participants for this enthusiastic involvement. Your active engagement will be crucial in making this program successful and impactful. To the organizing team, thank you for your tireless efforts and seamless coordination, which have been crucial in planning and setting the stage for this inaugural session. So as we look forward to the next 6 days of insightful sessions, collaborative learning and knowledge exchange, let us work together to make this FDP a grand success. I'm confident that the spirit of learning and sharing will lead to remarkable outcomes for everyone involved. Thank you all once again, and I wish you an engaging and fruitful journey ahead. We're slightly running out of time, and we'll be shortly starting the technical sessions. Have a wonderful evening. Thank you.
Thank you.
Thank you, Dr. Sinha. We wish all of you to make use of this opportunity to learn, share, and grow. So let's begin this journey of learning exchange and professional development in earnest and with perfect commitment. Next, moving on towards the first session of day 1 of this FDP, let us introduce Dr. Debashish Das for his knowledgeable session on quantum-driven future intelligence rapid response system. But before that, let's know about our respected speaker, Dr. Das. Presently, Dr. Das works as an associate professor in the Department of Computer Science and Engineering. Also, he is the associate faculty in the School of Artificial Intelligence and Data Science at Indian Institute of Technology, Jodhpur, Rajasthan. He remains the coordinator, Center for AIoT and Applications of the IIT Jodhpur. His active areas of research interests comprises Internet of Things, devices, artificial intelligence, machine learning, and blockchain. Dr. Das has published around 150 research papers in top international journals like IEEE Transactions, ACM Transactions, etc., and in the top conferences. He has 20 sponsored projects and 2 consultancy projects to his credit. He received the Early Career Research Award in 2016, the Young Researcher Award 2024, the BRICS Young Scientist Award 2022, and from the Science and Engineering Research Board, Department of Science and Technology, Government of India. He has various research collaborations with premier institutions in India and different universities all around the world. He has been actively involved in various academic pursuits, both within and outside the institute. He has guided many PhD students, and many are still continuing their thesis. More than 30 MTech theses has been guided by him. He is also a senior member of IEEE and a professional member of ACM. So not to delay, Let's welcome Dr. Devashish Das for his insightful session of the first day of this FDP.
Hello, am I audible?
Yes, sir,
Yes,
you
sir.
are audible, sir.
Okay, just I'll share my screen. So my slide is visible to you?
Yes, sir.
Okay. Okay, very good evening, all of you. I'm Dr. Devashish Das from Computer Science and Engineering Department, IIT Jodhpur. And today I'm going to discuss this thing, the quantum-driven future intelligent rapid response system. Okay, basically the quantum-driven future intelligent transportation system. Okay, so here why we need the quantum. Okay, and why? So this workshop basically more focusing on the development of intelligent system based on the AI and quantum. So today's topic also I'm going to discuss this thing based on the AI and quantum, but application is intelligent system. Here it is called the intelligent transportation system. Okay, so now, intelligent transportation system, basically here we mentioned this intelligent transportation system is at the Internet of the Vehicles based intelligent transportation system. So basically, which problem we want to solve? We solve the problem is basically environmental monitoring and rapid response system related problem. And how we solve? We use the intelligent transportation system and we use the concept of AI and quantum computing. So the title is under the overall the talk summary of this talk is in the quantum driven Internet of the Vehicles based approach for environmental monitoring and rapid response systems. Okay. So what is Internet of the Vehicles? Internet of the Vehicles means vehicles have the internet connectivity. Okay. And through this internet connectivity, vehicle can communicate with the other vehicle or vehicle can communicate with the other entity like the roadside unit, infrastructure, or any IoT type of devices on mobile phone as well. Okay. So this vehicle, they have the capability through this, they can communicate with the other vehicles as well as the infrastructure. Okay, but why they want the communication? Because they want to exchange some information. This information, it can be your location related information, some warning type of messages for the emergency vehicles. Okay, some assistance type of messages. Okay, and through this communication, we also can manage the traffic. Okay, through this, we can also control the accident. Okay, through this process, also we can monitor our environment. Okay, and or through this process, we can also manage the pollution, sound pollution, air pollution type of thing. Okay, so all these cases we have to have the IOV or like the V2X type of communication. Sometimes it is called the vehicular ad hoc network because communication between the vehicle. So that's why they create the one special type of network which is called the vehicular ad hoc network. Okay, so these are the vehicles and they can move into the different direction and through this they can exchange their information. Okay, so now like why we need such type of communication and through this communication what are the benefit we are getting? We are getting the benefit for the road safety. Okay, because day by day increasing the number of accident. Okay, from the brief joint statistical report, if you check, so then based on the data, it is 2.5 billion accident, okay, occur, and as well as the 50,000 of the death and 4 million of the injuries. Okay, so day by day increasing this thing. Okay, so and as well as if you check the year wise, also day by day increasing the number of death, injuries, and accidents. Okay, so similar type of things happen into the not only the India as well as the every state as well as the country. Okay, all the country have the similar type of problems. Okay, so now why we need this type of network? Through this exchange, we can, first one is we can reduce the accident. Through this network, we can reduce the traffic jam. Okay, so and as well as through this network, we can also exchange the informations. Okay, so like the large number of application also in the case of vehicle, we have like the Ola Uber type of services. Okay, and as well as the route recommendation systems. Okay, multiple things are there. Okay, so which is also we are getting the benefit if we have the this vehicle to X communication, or we have the internet the vehicles, or we have the vehicular ad hoc network. Okay, so in this case, what are the benefits? Okay, and these are the multiple problems occur due to this communication. Okay, so this communication is V2X, sometimes it is V2V, V2I. Okay, so all these cases, we have the different types of communication. Their behavior is different types of channel. We have the interference, okay, in the channel. Okay, so multiple disconnection is there because vehicles are highly dynamic entities, so multiple problems occur. Okay, some other problems like related to the scalability, integration, applicability. Okay, manage infrastructure, error rate, bandwidth, delay, latency, all these types of problem occur. Okay, due to this, there's another issues. Okay, so one issue is that we solve this problem through this IOV type of concept, but again we have the other issues. Okay, but how we solve the both type of problems? Okay, so then the current solution is fails to maintain the quality of service. Okay, whatever the solution we have. Okay, so as well as so that's why the quality of service is an important thing. Okay, as well as the vehicle is then the frequently change their speed and direction. Okay, so the network connectivity is not stable. So there is another challenge. Okay, a robust infrastructure. Okay, so scalability is then there is the issue. Okay, and as well as the mobility management and other problem as well as. Okay, quality of experience also the problem, improvement of the quality of experience, which is important in this case. Okay, now we can how we solve this thing. So we can solve through this AI, and we can solve this both problem, quality of service, quality of experience, and other thing. Okay, through the our technology V2X or using the vehicular ad hoc network. Okay, and as well as we also using the concept of AI and quantum computing. But how we can solve this problem through this? Okay, so like in this case, so these are the things. Okay, so we develop the solution. The solution is that the adaptability is there, stability, connection thing, flexibility, and resiliences. Okay, so these are the things we want to solve. So now, in this case, like whatever the solution we can solve. Okay, so if we have the like some validation, so we have the some autonomous vehicles lab here. Okay, through this we solve this problem for the small scale. Okay, here we create the vehicle. This vehicle have the such type of connectivity. Okay, so we create this type of vehicle. Okay, by our own, and we okay purchase the different type of component of the vehicle, and this component basically responsible for the create the V2X communication. Okay, so this is the, and now in this vehicles, now our objective is in this vehicle is only the have the microcontroller, camera, and battery, and other Wi-Fi module, and all those things. And here we now want to use the AI model here in the vehicles. Okay, for the different type of detection and prediction thing perspective. But which type of detection and prediction? Like we want to detect or predict some obstacle. we can focus on the what is the some lane changing thing, okay, or we can also identify the speed, how to increase and decrease the speed of the vehicle. So all those things we can through this AI concept, and as well as the learn the pattern of the road. Okay, so all these things we can do through this vehicles. Okay, so that's why for, and here the like deep reinforcement learning based concept, existing concept are there. Basically, we are focusing on these three techniques. Okay, like either policy optimization or Q learning or hybrid type of concept. Okay, basically these are the traditional thing. So we can use this thing for the whatever the prediction, detection of the lane, okay, as well as obstacle, all those things. Okay, so what type of application? Why we want to develop such solution, AI-based solution for autonomous vehicle? Because for the self-driving car, also we can use such type of thing. Okay, or partially now it is the car isn't the not human driven, but this is the automatic car. Okay, so multiple thing like we have the cruise control, such type of thing also do through the V2X type of communication. Okay, then the mining robot in the case of some organization, mining organization or something sale. Okay, so they have the mining robot and they also have the V2X type of communication is needed for their case. Okay, and same thing for the airport. Okay, luggage shifting from A to B, they use the robot and they also focused on the AI based concept. Okay, and as well as the warehouse also we use the similar type of thing. Okay, so now the objective is under just obstacle placement. Okay, and as well as the prediction, road dynamics, traffic thing. Okay, lane changing, turning decision, safety. Okay, all these things we can through this process we can solve using the AI. Okay, so now what type of communication in general it is possible? Either V2V communication or V2X communication, or basically internally two types of communication, one is the intra-vehicle communication and inter-vehicle communication. So V2X is the inter-vehicle communication, and when the inside the vehicle we have the music player, we have the different other components, okay, which is connected with the vehicle, which is the intra-vehicle. So we can focus on the both type of thing. Okay, so these are the different model. Through this model, the movement will occur. So we use this model for the different type of applications. Okay, movement of the vehicles. Okay, so now we in the case of deep learning, like this type of boxes we have created, and through these boxes we identify the object, and through this object we count the number of object, number of vehicles, type of vehicles. Okay, as well as the zebra crossing, as well as the lane changing, all type of things. Okay, so like this type of thing, we can count the total number of the vehicles, object, and such type of thing. We have developed such type of solution for this. Okay, so this vehicle as well as the real vehicle also, we develop the solution for real vehicle as well. Now, these are the test bed we have implemented. Okay, so like something is related to the deep learning based or AI based platform where we V2X communication we have implemented, and what type of benefit we are getting, what type of performance we achieve, and similar type of the driving behavior monitoring system implemented, and like the AI based, like the pollution detection is also implemented. Just I mentioned that this thing we can, if we control the V2X through the V2X communication, we can optimize the pollution as well. Okay, so now we also use the not only the vehicle. Now we mentioned vehicle to X communication means drone also can communicate with the vehicles. Okay, so then also we in this case also we create the one X means drone also, or UAV type of object. Okay, so then what type of information they can share with the vehicle. Okay, so like sometimes the traffic, what is the traffic camera is not able to capture the whole information, then we can use the drone. Okay, and through this we capture the informations, and through this we can update the current traffic of the specific region. Okay, so such cases we use the drone type of application. So like this type of application, okay, drone is connected with the traffic and we use the such type of communication. Okay, so vehicle to drone or vehicle to roadside unit or vehicle to traffic signal, such type of thing. Okay, and so these are the some concept we have used here in our models, like in the real life application, everything, all the machine learning model or AI model we executed into the cloud or in the server. But here we developed a new approach. We don't want to execute the whole model in our cloud. So we divided into our model into the subpart and executed into the in our like device level. Why? Sometimes we need the immediate response. So that's why such type of thing we can do here. We don't want to execute our whole model here. With part of the model we executed here, and finally the aggregated model we executed into the which is called the edge intelligence type of concept. Okay. So here overall thing, our objective is we collect the data from environment, and its data can be accident related data, mobility related data, crime related data, traffic related data, road network data, whatever, we create the data set. And then we apply the deep learning models or machine learning models. And through the visualization, we identify the accuracy, precision, recall, mean absolute error, okay, all those things. And through this approach, we can use for the different types of application like the crime prediction, accident prediction, fire prediction, okay, and water quality detection or prediction, such type of all activities. Okay, so this thing is under till now we are focusing on the like AI, okay, with prediction, but this prediction is challenging some of the cases because some of the cases our data is spatio-temporal, okay, and static data. Sometimes our data is spatial is and the static, temporal is dynamic. And the some of the cases which is challenging, which is we are working on it, which is the your spatio-temporal dynamic, means space-wise also dynamic, time-wise also dynamics. Okay, so such type of thing we focus here. Okay, and these are the devices we use for the data collections. Okay, now the question is like some type of problems, like in the case of deep learning problem, like the one just for your understanding. Okay, like why we need the machine learning or AI type of concept? Because we want to solve some complex problem. Okay, so what type of complexity we have? Okay, so like such type, like if we have to identify, and our objective is identify the what is the behavior of the driver. Okay, then we can think the okay. So if the driver behavior is normal, then it is eco-driving. If the driver behavior is aggressive, then the in this case, this is the your not good driving profile. Okay, it is the more pollution, more CO2 emission, more fuel emission, more accident, such type of thing is happened. So how we capture the behavior of the driver. Okay, so this type of thing, okay, is and the AI is responsible for like calculate or detect or somehow the calculate the behavior of the driver. Okay, so how it will calculate based on the different data and based on the pattern, driving pattern of the driver. So in this case also V2X communication is important. Okay, so basically Internet of the Vehicles type of thing is important. Okay, so now we are focusing on the till now the prediction, multiple thing. We can traffic prediction, we can accident prediction, we have the this driver behavior prediction, driver stress prediction, everything. We use the two things till now. One is our simple IOB concept. Through this we collect the data, and second one is through the AI model we can predict the behavior, traffic, all those things. Okay, but what is the challenge here? Okay, that's why we integrate the quantum. Okay, so the problem is the research addresses the critical necessity of the advancement. The rapid response operation is important for the environmental hazard. What are the environmental hazard? Like the leakage in the urban pipeline. Okay, like the different type of toxic gases. Okay, so this type of things is the basically challenging job. Okay, so like some example. of the sum of the gas. Okay, sometimes we don't, whatever the sensor we have, those sensors are not working properly. Due to this, we are not able to understand, okay, there is another toxic gases or something. Okay, so then such type of thing, all which are critical to ensure the public safety and environmental protection. Okay, so how we use the quantum computing and whatever the Internet of the Vehicles and AI, these three technologies to solve this problem. Okay, so this is our main objective. Okay, so we use the vehicle. Why we use the vehicle? Because the vehicle have the some sensors. Okay, and through the sensors we collect the data, and through this data we use the concept of AI and quantum computing to solve this problem. And then if there is anything happen, then such type of information warning message sent to the control center. Okay, but why the normal technique is not able to compute such type of thing? Because the normal technique is not able to capacity of the like all the area have the multiple types of vehicles. Okay, so all this huge number of computation is not possible through the normal computer. Okay, as well as the normal sensing is not able to capture such type of information. So that's why we use the quantum sensing type of concept. Okay, so what are the technique and why we use such type of concept? Okay, what is the need, really we need or not? So such type of thing we'll discuss here. Okay, so name is QIOV, means quantum IOV. So we create the one framework which is the quantum IOV that integrates the quantum computing with the Internet of the Vehicles and AI to leverage the computational efficiency. So we want the more computation as well as the parallelism, and we use the quantum property, entanglement property of the quantum machine. These three things we basically our objective, and through this quantum property we solve the both problem, computational efficiency and parallelism, and as well as the decision making. Okay, so our approach involves the environmental sensor mounted on the vehicles for the precise air quality assessment. So we added the sensor on the vehicles. Okay, and then through this approach we sense the sensor data. Okay, or collect the sensor data. Okay, then after that this sensor are designed by the high sensitive and accurate. Okay, because this is the more critical, safety critical application. So that's why these sensors are the highly sensitive and accurate, and leverage to the principle of the quantum machine to detect and measure the environmental parameter. Okay, which is the like the gas related information, quantity of the gas. Okay, and toxic gases. Okay, carbon monoxide emission, such type of thing we have to, as well as the like some leakage of the urban pipelines. Okay, so such type, or as well as the industrial release of the hazard gases, such type of information. So what is the motivation? So silent feature of our work is that we use the quantum mesh network fabric. Okay, which is a system designed to the dynamically adjust the quantum network topology in the and as well as with your vehicular movement, both things. And our motivation is on the we capability to the critical and to maintaining the integration of the quantum state, again the environmental and vehicular concept, and as well as the reliable data transmission and processing. Okay, so this thing. So in this case, based on this, we develop the solution which is the quantum enable IoT framework. So here we have the quantum thing, and where we use the quantum concept. Okay, and where we use the property of this three concept. Okay, one is the your computational efficiency, which is we want the parallelism for the quantum, and we need the entanglement of the property of the quantums. Okay, so our urban and industrial area, basically we are focusing on the urban and industrial areas, increasing the exposure of the environmental hazards that pose the significant risks in our public and society as well as the health. So this is our main concern, and this consequences of the such hazard can be like the disordering, and as a historical incident, like the different type of historical incident of the such gases like the Bhopal gas tragedy. Okay, we have the sensor, but those sensor is not able to some of the places not sense such type of gases. Okay, same thing the China coal gas leakage. So this type of problem how we solve through the quantum. Okay, as well as the US gas pipeline leakage and many more type of such type of incident occur. Either sensors are not working or there than the some of the places there is no sensors. So how we solve this problem? So here we use the IOV, whatever. So this thing is under basically solve this problem. Okay. So these are the different gas incident which is occurred. Whatever the we have the emergency system, those system is basically not work properly due to this type of incident. So how the quantum computer is under a quantum solution or quantum IOV, whatever we develop framework. Okay. So which is responsible for solve this issue. Okay. So the same thing is under like multiple similar type of incident. Okay, and now what is the here we have done? Okay, we have done the here like any type of gas or leakage is there. So then basically vehicle is sense the such type of nearest in the parking area. Whatever the any parking area, all the vehicle have the such whatever the vehicle till now the normal vehicle what type of sensor they have. Such type of sensing thing, we sensor is capture the such information, and this information they send to the our quantum setup wherever the quantum setup we have. Okay, which is our infrastructure, and this is the V2X. X means our infrastructure. Okay, and then we have the quantum property, quantum entanglement. Okay, data conversation like we whatever the data we collected, which is the normal data. With this conversation, we convert into the normal data to the quantum state. Okay, and quantum data, and this quantum data is computed here in the quantum server. Okay, and through this, whatever the output is there. Okay, like the whatever these gases, the sense this gases is under with the threshold or outside the threshold. Means these are the toxic gases or such type of information is sent to the multiple authority. One is under hazard alert to the society, its control center, other vehicle can send to the other. So this is the our main concern. Okay, so here the what is the responsibility of the this IOV is only capture the information, and this quantum computer and this quantum whatever the solution was proposed. So this solution is convert into the normal data to the your quantum state and compute this thing and finally send back to the data to the corresponding authority. This is the our concern. But here why we need the quantum? Because we have the huge number of the vehicles. Okay, and huge number of computation is needed. Okay, as the immediate response is important. So that's why the quantum computer and quantum server, this is the plays an important role. Okay, for this as well as we use the quantum entanglement property and this as well as the quantum data conversation. Okay, so now through this, what type of sensor we use? Okay, because it's not like we just develop this this thing concept and this algorithm, this framework. That's it. We proof it. Whatever we develop, this thing is the correct. Okay, so in the vehicle, we basically use the different type of sensors. Okay, these are the sensors we consider. Okay, and we assume this type of sensors are in general available in the vehicles, and we also mentioned in the different points. Okay, where this type of sensors are available in general in the traditional car. We consider those type of sensor, and we also need the V2X type of communication. Through this, we can communicate with our quantum server. Okay, and then what is the contribution? Contribution here with the we use our novel concept or encoding scheme. That's aligned in the multi-dimensional sensor data with the quantum state, whatever I discussed. Okay, because and it's like the getting the different type of smell to the from others. So this vehicles is now we use for the sensing the different type of gas related information. And if and the quantum computer is and the predict the such type of gases using the quantum AI concept or quantum machine learning concept. Okay, and then we can give the correct thing. Okay, so then we propose this multi-parties entanglement. Okay, not single parties because we have the multiple vehicles, so multi-parties. And here we have the use the quantum entangled future maps, and as well as the sum of the controller thing we have used in our quantum operation. Okay, so qubit across the different vehicles. Okay, and utilizing the controller Z and controlled X. Okay, gets into the introduced for the correlations. Okay. And so because the correlation is important in this case, okay, and then so our method is and the augmented the incorporating the variational quantum classifier we have used with the advanced quantum entanglement techniques, which is mentioned the multivariate entanglement type of concept. Okay, and this integration offers the significant reduction of the latency. So we have modified this thing, so that's why we reduce the latency, and which is important for the hazard alert transmission. Just I mentioned not only computation as well as the quantum communication easily transmit the information, hazard related information, which is also important, and enabling the communication for the critical data, okay, as well as the crucial data to the emergency teams as well as the public. And in this case, we use for this validation purpose, we use the IBM Open QSAM platform, 3 platform. Okay, we use the 123-bit qubit system, and we also achieve the accuracy, precision, recall type of thing. Okay, for the verification and validation of our system. Okay, correctness of our system and more reliable system, as well as the speed for the toxic gas detection compared to the conventional methods. Okay, and as well as we done some theoretical analysis for the efficiency of the quantum rotation. Okay, as well as the fidelity of the quantum entanglement and all those type of things. We have theoretical analysis we have done. Okay, and the results. So we have the just I mentioned we use the IBM Open Simulator QSAM 3 platform and 127 bits, and we category of the 4 type of the thing we have done. So you can categorize the more. We can categorize that in our experiment only for no gases. Okay, and perfume, CO2, CO. Okay, so this type for validation purpose we consider that this 4 category, and this is the result we achieved based on this simulator and quantum 127-bit quantum computer. Okay, and we consider the classes 1, 0, 1, 2. Okay, and these are the achievement we achieved. And as well as we also detection the time analysis over the number of data points. Okay, so we use the different algorithms. Okay, like the SVM random forest and our proposed one, which is a better platform compared to the others, number of data points and detection time. Okay, so our detection is faster compared to the other scheme. Okay, so these are the things we have done. Okay, so and as well as the now also. So if you have any query, anything, then I will be happy to answer those queries. Then after that, I will discuss the some. So any query from the audience or any questions?
Sir, actually, it is muted. Mic is muted, so we'll unmute it at the end of the session, and
Okay,
then we can ask the queries.
Yes. Okay, so last. Okay. Okay, so these are the things. So here the accuracy is also high, as well as our performance wise also we are getting the good performance compared to the other scheme. So now another concept we also want to add the quantum thing. So now it is everywhere we have the AI. So just in your all the speaker and the other like guest, they basically mention the AI thing. But if everywhere we use the AI, then there is a possibility, and deep learning, then there is a possibility the attacks. Okay, so like in the AI level attacks or model level attacks, as well as the sensor level attacks. Okay, as well as the input level attacks. So with device level attack, model level attacks, output level attacks, so different types of attacks is there. Okay, so now we are trying to develop the solution how the quantum computing, because large number of device nowadays in our mobile we have the AI solution, in our AC also we have the AI solution, AI TV, everywhere we have. So if some attack is happened, okay, and as well as if you check the report, so day by day increasing the number of attacks. Okay, so can we use the quantum like the similar type of in the case of transportation, okay, like the IoT type of solution. So here we can use the similar type of solution, and which is basically solve the problem, okay, like the protect the different types of attack, protect from the different types of attacks. So so here we basically check based on the, so like the accuracy due to the attack, so the accuracy level is also decreased. So can we through the quantum computer, if the fast computation, fast data transmission is there, then there is a possibility reduce the number of attacks. Okay, so such type of thing we have. Now we have the plan to we develop the solution. So we develop the sum of the solution top. So which is basically previous case the which is give you the in the case of vehicles will give you the some information or alert message. Here the quantum computer give you the attacker behavior or basically predict the or detect the attacks. Okay, so these are the things. So I have the expertise in the similar type of domain. Okay, and we have here the vehicular ad hoc network lab. So here we have the large number of students. They are working in the quantum as well as the machine learning, IoT, distributed systems. Okay, and so this is the Vanet lab at IIT Jodhpur. So thank you. If you have the any query, then I'll be happy to answer your query.
Okay, participants, if you are having any query, we are just unmuting everyone and you can unmute yourself and ask the question. Or else raise your hand also. I think one of the participant has raised your hand. Okay, we are just unmuting you. Yeah, I think S. Buchi Babu, you can ask the question because we have unmuted you. Are you having any questions? Yes, any other participants?
Madam, actually at that time I have not received the audio. That's why I am raising the hand.
Okay, no problem. Okay, any other participants who want to ask questions related to this topic? Okay, Yadav is saying, I'm just unmuting you, sir. 2 minutes. Yeah, I think you can unmute yourself and you can ask the question.
Hello. Sir, so you're talking about 4 types of attacks: sensor, input, output, and model level attacks.
Yes, yes.
Can the integration of a blockchain can also be included in this pipeline network?
But why we need the blockchain? Blockchain is a costly technology.
Okay.
Okay, so then we think which blockchain give you the solution. There is a possibility. Okay, but the blockchain is a costly technology, and till now means not like the any type of devices we use the blockchain. Like the banking people, they use the blockchain for the financial transaction. Till now, some of the banking application they implemented. But blockchain, we have to think the blockchain because you have to have the distributed environment. It's not like the everywhere you want to use the blockchain concept. Okay, if you have the distributed environment type of thing or such type of application, then you can use the blockchain. But here, our this thing attack, whatever the attack is there, which is our centralized system. Okay, so we think which type of attack, but these are the possible attacks in general, like the sensor level attack. So if the sensor somehow the what type of when they fabricate, what type of means like different type of components are important. Okay, so there is a possibility the somehow it is not like that. There is a bias thing is there. Okay, so then
Yeah, yeah.
automatically your output is incorrect. Okay, whatever the
Yeah.
sensing thing. So such type of thing we can, how we check and how we validate. Okay, how the
Okay.
your quantum computer is responsible for the solution. But we are till now more focusing on the this model level attack, because everywhere we have the model. So then this thing, but blockchain can be a solution, but which is costly solution, we have to think.
Okay. Okay. Thank you so much, sir. Thank you. Right. Right.
Okay, any other participant who wants to ask any questions related to the topic? Please raise your hands. We are going to unmute you. Okay, Dr. Pradeep Singh. Okay, we have allowed the mic for you, sir. You can ask your question. Dr. Pradeep Singh, you are unmuted. Yeah.
Yes, am I audible?
Yes, you're
Hello,
audible.
yes, you are.
Yes, good evening, sir.
Good evening.
Yes, just I wanted to ask that what is the current status of quantum computing, or are we having any quantum computer right now? If we are having it, that what is the number of quantum computers that we are having right now?
Like till now, whatever the implementation we have done through the IBM simulator for the validation purpose. Okay, IBM quantum simulator for the validation, and we have the some of the quantum edge type of devices, and while we execute and communicate the some of the small, we created the some small test bed, and while we perform the some quantum communication and quantum computation. Okay, and but basically in general, like in this case also we use the IBM simulator. Okay, for the validation purpose, and we use the 127-bit qubit type of concept.
Okay.
Okay, for validation, whatever that we develop, so this thing is correct or not, and whatever the result we are getting, and we compare with the whatever the till now solution, theoretical solution available. So based on this, we compare this.
Okay, so I was just asking that what is there on ground till now?
On ground means like till now in India, IISc Bangalore is under the quantum lab. Okay. And they already have the some of the quantum computing devices they already deployed. And here IIT Jodhpur, we also have the Quantum Interdisciplinary Center for Quantum Computing and Communication. Okay, Quantum Information System, where we have the MTech in Quantum Technology program. Okay, where we have the some small type of setup, where we do the whatever the computing, communication, and quantum computing, quantum communication, and quantum sensing related experiment.
Okay.
Okay, but in that big level, we don't have the big infrastructure, but we have the this thing for the we have the program, so some experiment, and as well as in the research we have done the multiple like algorithm developed. Recently we are working on the post quantum cryptography, where we identified the whatever the post quantum algorithms are there. So what are the issues in the algorithms and how we solve this problem? So such type of things are ongoing.
Okay, thank you, sir.
Thank you.
Okay, any other participants who wants to ask any question? Please raise your hand. We are going to unmute you. We are just having a short question answer session. Anyone wants to ask anything related to the topic, you can please raise your hands. Okay, sir, then I think we'll come to the end of this session. Another session is about to begin. Within 5 minutes, we'll have a break. Before that, we would like to propose the vote of thanks to Dr. Debashish Das, sir. Sir, it was a really very interesting session on AI quantum computing, and it gave a lot of insights to our participants. And we are going to have another session with you tomorrow. So I hope we are going to. Okay, one more question came. I think Mr. K. Praveen. I just allow. Yeah, Mr. K. Praveen Kumar, you can unmute yourself. Do you want to ask any question, K. Praveen?
Yeah, yeah. Am I audible, ma'am? Yeah.
Yes, you're audible.
Yes, you are.
Very good evening, sir. What could be the difference between this big data analytics and the quantum computing, sir? How these both are? Because big data also handles the large amounts of data, ma'am. So
No, data is large, but you can handle the such type of data through the like GPU based system or high configuration CPU based system. Then why you need the quantum computer, which is costly technology? Okay, so then some of the cases like like in this case, whatever I discussed, which is the we need the some data and data also convert into the from normal data to the quantum state, and we need the immediate response. Okay, such type of application when we need that we can apply, but there is the relationship between the big data. When your data is huge, then the more computation power is required, then you can move, but it's not mandatory. Like every time quantum computer, GPU based system nowadays also available. Through these also you can compute such type of computation.
okay, sir. Thank you.
Okay, so next participant, Miss Nita Rehapade. I think she wants to ask some question. I will just unmute you. Yeah, you can unmute yourself. Miss Nita, if you want to ask any question, you're unmuted.
Actually, madam, I have network problem, so by mistake
Okay.
I tapped that.
Okay, no problem. Fine. Okay, any other question from the participants? Okay, then I think we are about the end of this first session. So session 1 is about to end, and we are really very thankful to Dr. Debashish Das sir for his insights on this quantum computing, and we are looking forward to hear more from you on tomorrow's session. So thank you, sir, for a very nice address. Thank you.
Thank you. Thank you.
All the participants are requested to be online because very soon our next guest, a resource person, is going to join, Dr. Suman De from NIT Agartala. So just we'll have a short break of 5 minutes. You can be on the session, don't leave the session. And we'll be starting the session in a short while. Satya sir, can you put the poster of the next session?
Oh, yes, ma'am, of course.
Our resource person for the next session has already arrived, Dr. Suman Dev, sir. Sir, yeah, you're visible on screen. I hope you can unmute yourself also. Okay, fine.
Yes.
Sir, just 2 minutes. We are about to start the session.
That's fine. Is my presentation visible?
Yes, sir, it is visible, sir.
Perfect.
Satya, sir, I think we can directly start the session. Can you please start? Satya sir, are you there?
Yes, ma'am.
Yeah, can you please start the session?
Is my voice audible?
Yeah, sound is little lesser. If you can speak little loudly.
Sure.
Okay.
Good evening, everyone. Welcome to the next session. We are here with our next presenter, Dr. Suman Dev. He's a faculty member and immediate past head of the CSC department, NIT Agartala. He is also the Associate Dean Academic and Chairman, Institute Innovation Council and Startup. His main research area includes visual intelligence as a specialized application of artificial intelligence, robot vision, human-computer interaction, and education technologies. These are mixed with critical issues of augmented face-to-face interaction. Innovations in teaching learning method is a continuous endeavor of his work. He is also the faculty in charge of HCI and AI lab of NIT Agartala. He leads a vibrant research group named Visual Intelligence and Machine Learning (VIML) at NIT Agartala. His team has deployed various low-cost innovation in access control, humanoid robot, skeletal movement analysis, ROV and AGP path plan, SLAM visualization, etc. Apart from active academics, he is also better known as the designer of both NIT Agartala and IIIT Agartala logo. His paper selected among top 3 during Indian International Science Festival at National Physics Laboratory, New Delhi. He has won several best papers during international conferences like India Arctica, CNC, Mind 2021, ICCA 2021, etc. He has multiple patents and developed very low-cost indigenous braille printer. He has authorized more than 11 edited volumes and book chapters, 3 textbooks with more than 80 research articles published in significant journals and conference proceedings. He has guided more than 27 PG and 44 UG projects along with 5 PhD continuing students. He has organized more than 37 national FDPs, workshops including 4 prestigious international conferences, national level hackathon. He has received multiple research and consultancy grants that include prestigious DST Impring project and qualified for establishing AIM AIC grant accounting to 10 crores. He is the honorary director and mentor of the startup Cubo Bots Private Limited. From VIT family, we welcome Dr. Suman Dev for this wonderful session on quantum image processing. Very welcome, sir. You can please start with the session.
Thank you. Thank you so much. Hope I'm audible.
Yes, sir. Of course.
Okay. So my slides are visible. Hello.
Not yet, sir. Yeah, now it is visible, sir.
Okay, fine. So audio, video, both are perfect, so I can continue. Is this fine?
Yes.
Thank you so much. So really, it's a wonderful opportunity for me to interact with you, not just as a person of area in quantum image processing, rather just like any person who are working in image processing and etc. They always find out what is the new avenue, how we can start a new way of processing whatever the existing system. So when I first got this call to be a part of the whole FDP, it was thrilling experience for me, as I'm not directly working into quantum image processing as a lab experimental matter, but okay, partially working. So that part I'll be sharing with you. So equally, it was a very interesting part to accept the invitation and also today prepare the experiences so that I can share with you. Just immediately before this session, the expert discussion was wonderful, and I was apprehending something like that the first session will be such a manner you will be having a that means a little bit of idea or almost a idea about this quantum matters or quantum image processing in particular. Now, if you see, the whole matter of his hardware, software, and algorithms are very new. We hear the terms only, or even sometimes Google, but very few people are exactly working into quantum processing, quantum processor, or quantum image processing in particular. So naturally, I expect that among the audience also, some very few people are there who are hands-on working into quantum image processing. And at the first, I express my all limitation and also the way I'm perceiving this quantum image processing will be a kind of that how our existing system can be mapped with the quantum image processing. So I just thought to make the whole discussion into very clear three major segment. The first segment comes the existing whatever the image, visual processing, etc. So I'll request all of you that feel free to have an interactive matters so that at any moment we feel that these things are along with our existent some experience and which can be mapped to others, that will be our point of takeaway. So we will flow the whole matter in such a manner. It is a wonderful to see such a large number of participants from throughout the country. And I'm from Tripura. As in the map, you can see, and a very beautiful notch part of our motherland. And from there, I'm sharing my experience with you. So definitely this is going to be a very interactive and nice experience for all of us. Now, I've not gone through the previous session, so I apprehend things will not be repeating. But till the general essence of quantum computing thing comes into such type of flow, where finally it is a quantum image processing, a specific area of quantum computing. Largely, we know it's a physics dominant matter. People have a very strong resonance of physics, and then it has been mapping towards computation. So that till it is in an experimental stage, that how it can come up with a cost-effective manner and an effective computing in comparison to the traditional or conventional system. Now, as you know, this quantum computing is the first important part where you should be thinking of, because all story comes here, make the computation very effective. And then quantum images, because the image, whatever is our traditional way, that cannot be given for quantum computing directly, and quantum information processing. So I thought to just put this mind map so that all of us in a clear position that three prerequisites are important to get quantum image processing. That's a very niche idea. Now, quantum computation, which exploits definitely the parallelism. Now, this parallelism has a clear goal that classical computations or computers, which they cannot do in every segment in an equally good way, can quantum computers or quantum computing can be intervened there. So as we are dealing with two components, computation and image, so definitely the image required to be presented in a specific way. Now, generally, when we talk about computer vision, we see computer and these images has a relation of matrix. Very clearly, it's a matrix. Whether it is a 2D matrix or 3D, that's a specific zone area, but it's a matrix. Now, whenever this matrix comes, the conventional mathematical calculations are dominant, and we are comfortable with that. Now, here requires a physics intervention. We require to present the images into quantum bits and so on. We will be having a discussion. But what is our intention? We need speed to increase security, storage, that means minimization. And there are two properties, entanglement and parallelism. So this is a definite parallelism comes where to minimize the time we can understand, and different other computational terminologies important. Here, a lot of text I put in this slide just to make the discussion more easier. And when I am discussing, you can also read the slides and you can find out things are very in line as a human processing system. Now, as a human are having major 5 sensors, but those sensors are highly dominant by the visual sensor. Even we see the information and we can process partial information. Now, when these large visual informations are processed by human brain, similarly, nowadays, large number of camera or visual things are around us. Let's take an example of traffic data. Let's take an example of security, that means surveillance data. So those large visual information, if we want to perceive any meaningful data, we require definitely large computational power. Even to be more specific about traffic and this surveillance data, there is another data. Nowadays, every people are clicking photographs, and on an average, people are clicking at least 10 photographs. So if you multiply almost all the mobile holders multiplied by roughly 10 images or even 5 images, then you can find out huge volume of information is coming up. Now, where those informations are definitely stored in distributed way, and if we want to retrieve some kind of meaningful information out of it for some kind of specific reason, so you can find certain, specific, all those terminologies are very common nowadays. So one thing is coming Instagram, another is coming, say, Facebook. So large images are there, maybe public images, and if we want to retrieve some information, where those computation can be done. So that's why a thought process came up for increased computation, and the magnitude might be larger than the existing system. So that type of thing is very important. So I will more focus into computer vision part. So how the computer vision is exactly identified. So we have a clear 50% of discussion. One will be on human-like computer vision. Another will be computation through this quantum processing system. Now, if you just search on internet, you can find out there are not huge resources are available on quantum computing. The resources are there, but very limited and very specified. The first point comes up that whenever it was first conceptualized, it had been in three major areas: quantum assigned digital image processing, QDIP, optics-based quantum image, and classically inspired quantum image processing. Now, as we have that much of very clear idea that image processing and image capturing, all those things are separate component. So the moment it comes image processing, definitely there are related manipulation comes. So this manipulation is an inherent part of the whole processing. So I wish that these 3 points to be noted for our discussion: QDIP, OQI, and QIMP. We will discuss primarily on QIMP, that is quantum image processing, which is classically inspired. Now, this classically inspired part is the main core of my discussion. In course of this next 5 days, we will be having very expert speakers into all the technical domains, mathematical derivation, representation. So this classical inspired part I will be touching, and hope that other quantum detail information you will be getting over through. Now, the question comes, what is quantum computing? Hope that has already been communicated and all of us having at least some idea. But till to make it more clear and redundant, these few lines are important. That exactly how things been inspired, that quantum computing, multidisciplinary field, where computer science, physics, mathematics coming together. Now, when they are coming together, we have a distinct problem solving. That means these problems are not only related to computer science, but they are across. But here computation comes as an important part. Now, as I told you at the beginning, very honest confession that when I first received the topic, and I was about to deny that. But then I realized that denial will be very simple, because I am not a core worker into quantum, that means computation system. I'm a person of computer vision, and like me, a lot of people are there in the audience who are working in computer vision. Why not to just have my problems as their problem and discuss how this can be mapped, or let's realize it. So this quantum mechanics, which is a known part to us and which is more confident that how the physical components are working, that is a microscopic level or subatomic levels, and how they are presented. So definitely this is a very complex equation, complex representation. But if we talk about images, that quantum or subatomic systems can be mapped to our very simple pixels, picture elements. And those picture elements, if they're mapped, we can find out or derive the information out of it. So naturally, there is a thing called quantum bit. Now, these quantum bits are represented these quantum particles. Now, these quantum bits, they require a way to present image or visual information. So that's from there the thing comes. And how the classical bits, as I mentioned, if there is a image and we can map the image from like normal bitwise operations or normal any kind of representation, JPEG or so, they all have finally a bit representation. So classical computation, electronic signal, these are on or off signals. Now, can we make these qubits based on law of quantum mechanics? So these quantum mechanics required to make a nice mapping. I'll try to just mention those terminologies. So this principle of quantum computing, like superposition, entanglement, and decoherence. So these three parts are very important for us to realize that from our respective domain, how we can communicate all those terminologies into a processing part. So definitely superposition, where much like this classical physics. So here the lines are exactly taken if it is not to be misunderstood that two or more quantum states and results will be another valid quantum state. This is a conflict with our present understanding of Boolean logic or etc. Now in Boolean logic, we apply operators like say two bits are there, A and B, and different transition systems or states you can combine by operators. But it's not so straight that just by operators a third state can be achieved. So this type of matters we have to find out as a terminology called superpositions. Now entanglement, quantum entanglement occurs when two systems like so closely and are given immediate knowledge about the other. So we have different derivation, and I will refer some of the papers also where you can find, and at least 10 papers are there which are all related. That means people are trying to map their problems towards such type of classical definition. Now, if you see decoherence, it's a loss of the quantum state in qubit. So you can imagine right now that these three things are very connected, and we want that two states to be giving an information of the third one, and we can find out a large challenges can be mapped to that part. So quickly I will be coming to this quantum image processing. So this merges mechanics and image processing. Now question to all ourselves, if there is a simple image and if there is a term comes image processing, what are the changes happens? The first change happens manipulation. This manipulation is a positive way. That means we want to extract more information, we want to enhance more information, etc. Or we want to get some kind of classical, that means some kind of filtering out systems. Now, image processing involves modifying visual data. Clear line modifying visual data. So one image is coming to us. If we are not modifying, that means if we are not extracting the data, it is rarely that we can find out the usable matters. So quantum bit exploits superposition, entanglement links qubit regardless, and quantum parallelism for faster solution. I hope these 3 points are very clear for us that how the quantum computation or quantum representation may be a bit classically connected. Now, this has been collected from the application paper. This is flexible representation of quantum image, FRQI, and they have applied different techniques that how specific methodologies or techniques can be used to represent. And that is one is flexible representation quantum images. I'm not going deep into that. I'll just refer the paper. You can take the paper and go detail into the systems. So my point is here, once we do it, till now I've just made a 10-15 minutes discussion on a basic part. Now I'm just slowly moving to the vision. Now how exactly this vision part comes into picture, and we can take a bidirectional mapping of both the things. Now let's talk about physics. So as quantum computing coming into physics, the vision that senses like color, structure, etc., all are presented or given to us, our brain. It's given by a structured information, but which is a physical quantity. At this moment, as most of the audience are muted and visuals are also down, I'm talking to my slides and myself only. But I'm assuming that all of you are getting a very tidbit idea. You are expert. Many of you might be expert and very top researcher into the area, that the physics is presented to us for computation in terms of color characteristics, in terms of structural representation. And then we are trying to find out the vision into that by extracting images. So vision and image, they are very close, but may not be same. I don't know how far the statement will be correct, because the moment you call image, you have a clear description, a matrix. The moment we are calling visual informations, lot of other characteristics also we can add. Here, an image is presented by pixels. It's known to us, these picture elements primarily is a two-dimensional matrix. All these bits are having colors representation in a gradient of, say, some bit information, which are presented as a matrix format. So in this matrix format and the quantum characteristics we have seen, the parameters are only changing. That means here, the image is not getting changed. The image as it is. Only we are trying to find out how these metrics can be mapped or some kind of computationally efficient representation. But yet, I personally can understand when I was trying to inquire about this quantum computation and this mapping, traditional computers and quantum processing systems have a large computational cost difference. It's not so that at this moment, it's a very easy thing or it's a very faster thing. Till the traditional systems are better, faster, but the progress and growth is showing and apprehending that maybe the hardware cost, the whole infrastructural systems will be reduced and computationally it will be exponentially high. So that is an agreed upon matter. So if we move further, there are multiple channels. You might be now arguing that slowly I have left this quantum part and moved to this traditional part. Yes, I have. Because my expert areas I should be coming up, and only I'll be sharing that new avenues where we can put those things. These channels are known to us. Now, if every channel component and matrix, whatever traditionally we do, we can map a channel of different processing, then we can find out it may be reduced to smaller size of programs and smaller size of identification, and then it may be processed in a quantum representation. There are various ways people are applying. So, as a simple matter, how do you find out the quality of an image? Now, this quality of an image, just there is one example of histogram representation. Quality of image doesn't mean that it's intensity values. That is how the distribution of image pixels are there, brightness distribution. So if we just think of to find out such type of problems, is it quantum computing important? So the common problems we'll discuss and we'll find out how the vision comes into picture. So that's obviously part of where meaning are added to the images. Like in previous slide, it is said the quality of the image. So quantitative, some representation, distribution, etc. Now, very simple question that how the computer vision is different from this quantitative data. So actually, we want to abstract the meaning out of the whole system. So this is my very favorite slide, and many times we have discussed with a lot of experts about this particular representation. There is an image. This image is not very, that means you can say special image, but there are some human level questions asked. What is this image? How you're going to describe it? You are finding that as a human, you are looking to the image first time, and different kinds of information you can share. It depends on your background. Now you look to the image and imagine how you're going to describe it. Some people will be describing it's a farmhouse. Probably it is beside a river. There is some hill. There is definitely it is outside India. Some people will say, no, it is in India. A lot of argument may come. Now the question comes here, how we can extract the best information out of this whole image. Definitely during our question answer session, we will be having, please remember, this is slide number 25. So the question is very simple, how we can abstract more information or extract more information out of this particular image. So any XYZ image coming to us, suddenly can we come to a conclusion about this particular image, and what kind of conclusion it is? It's a specific information or it's a general information. So a lot of things come. So these are some questions which are very specific. where you can apply the conventional system, what kind of scene it is, where are the cars, how far the building. But my question was different. When I was asking to human, that's why human interaction, that is what you think about this image, what you best abstract. Can you exactly identify the place? These are almost impossible, nearly impossible questions. So these are some of the things where we can find out vision comes into picture. Um, Honestly speaking, these particular examples, whatever I'm going to show you, it will just revamp our very early image processing system. So this early image processing system gives us the fundamental idea, which is almost similar as today we are talking about quantum computing for image processing. We are in a very early stage of quantum computing for image processing. So similarly, when I have given the Wikipedia link also, where you can find out the very early stage of number recognition. How this number recognition used to work in a very early, say 10 years, 15 years, or even 20 years back. Even how the face recognition on our digital camera used to work. These were very interesting examples. Now, smile shutter is one interesting feature. Many of us who are working into directly vision, so we know that face recognition, ROI, then different kinds of characteristics. So it comes as a pattern. We call it as a machine learning system. Mostly we call machine learning. Now, these can be action oriented. So these action oriented things are, this is a very common example. I'll give you 5, 6 more real life examples where quantum computing has its little scope with the, so that means I'll end it up with a very interesting conclusion or anecdote. All of our memories will be now revamped. I know that taking a session at evening time is really very difficult for all of us, because this is very difficult to digest that how things are technically happening. I think all the audience can recall this particular photograph, very interesting photograph. And you searched after this discussion about how this Afghan girl was, that means identified. You know that during Iraq war, this girl was captured by National Geographic on photographer. And later on, probably after 17 or 19 years, it searched on that whether that girl is still existing. Many people came up, but finally the identity was revealed by iris scan. Because you see that photograph and the present photograph has only two things that iris matching matters. So the whole story is available there. And this is very interesting photograph just collected from Wikipedia, that's internet. That is a vision of NASA's Mars exploration. In many cases, we know that these photographs are not taken by a single go. They are taking small, that is panoramic or timestamp matter. And these spatiotemporal systems are joined together and a large photograph is created. You can also search it on internet and you find out beautiful such large panoramic views created by smaller snaps. So all these things come in 3 major segments. I hope now it's interesting for all of you that I try to collect the whole system in 3 niche areas: computer graphics, computer photography, computer vision. So definitely it's interesting for us, for all the computer scientists or the engineers, models to image to image and image to model. And maybe quantum computing today we are talking, this directly coming up as image to model. So that image to model part is really important, how we can take it up. So I hope these particular things are very easy for us to at least connect the matter. Okay, as my area of work is to integrate several orthogonal matters and try to make a meaningful application. So what we do, generally in our areas, we try to take, say, robot vision. Now, robot vision is a terminology less larger component. We take a specific goal-oriented matters, that how machine can be seeing the surroundings or situational awareness. So that's why computer vision, machine vision, image processing all come together. Now, today in our discussion, new thing added, which is physics, and it's quantum computing. So this particular slide is an assimilation of our research domain. As such type of FDPs and workshops, they are thought-provoking. That means here in 1 hour or 1.5 hours, it is difficult for someone to just learn or teach. Definitely, we understand that limitation, but it's a thought-provoking system. That means how, when we go back after this session is over, your feedback will be coming up, and then you can think of, okay, someone of you are from mathematics department, some of you are from physics department. So how these things can be interrelated and interconnected. So we always keep the philosophy that this particular image processing or vision mesh system should be accumulation of different areas. I cannot remove one part and claim, okay, I'm doing this in particular area. Very difficult. So this is the spread up of all the components and how they are roughly interlinked. Now, my one intention is less computation or small computers, how these things can be done on small computers. So there's a process pipeline. Though this process pipeline is highly, that means influenced by several long time works like single board based computer. So the point is here, can we submit a problem like edge devices and can it solve that particular problem with a help of model which is created on a larger computer? Well, just let me make it very clear. Say IIT Jodhpur is having a very nice computation facility. They have made a model and the model has been proved. Can I adapt this model and put it in a smaller computer? And that smaller computer will be consulting that model and will be just using that model, which is traditionally we are doing in a large way. Now the question is coming up, if a model is taken which has been trained in a very high computational system, suddenly we are submitting in a small, and there is a little bit of exception or changes. So we have to make again retrain or some modification. The point is here, can small modifications be handled by such edge computers or smaller computers? By edge computers, I want to mean just like you can say Raspberry Pi, Jetson Nano, or such type of smaller things. Now, I just tried to collect several algorithms for this image recognition and different kinds of processing. Nowadays, it's a very trend. People go by the conventional models, make some kind of modification, retrain the system, and find out the variation or the success rate of their algorithm, which is a very common process of work. Now, this image recognition comes with specific purpose. Today, this example, we are very common that in GitHub or internet, such type of things are flooded. But try to understand, as it has been mentioned, that we are trying to find out a meaning of a particular image. Can a situation be given, which is called situation awareness about in that is image. Now, in this item, image recognizing which is car, which is human, etc. But can we get an abstraction, which is large language models are definitely doing, a lot of AI-based tools are doing it. But here computational cost is very high. So quantum computing may come up here as a distributed system or distributed intelligence system. So this conventional system had been placed here, we are all known, and we just try to find out how this recognition process can be again mapped. So this acquisition and etc. part, and here this model learning, model part and model processing part may be given to the quantum processing system. These particular things, which again, I'm coming to the common part like classification, tagging, detection, segmentation, all those things can take up with a smaller chunks or smaller particular systems. I'll quickly go through some of our works or some of our vision-based systems. I'll skip the slides just to make the discussion rich or the slides rich. I just try to keep all those general CV matters here. So the trends on future CV is coming as a one part, as today has been discussed, as quantum computing. So definitely this quantum computing or artificial general intelligence, whatever is envisioned, not talking about super intelligence, is not possible by any new avenues of visual processing. So this visual processing required to take a very simple, that means box-wise development. How far is done by this traditional system, it should be given to the next box, which will be processing of this quantum processing matters. Okay, there is a system that whenever we talk about the accuracy of model, now a very simple system comes. I want to apply quantum computing system and I want to verify in comparison to the traditional system, where the infrastructure is possible, where those infrastructure can be given. If an institute is developing, only when then you can experiment it. I may be wrong. but I want your feedback also. Where are the facilities available in India? Do we have a very clear picture of that? That I want to work in quantum computing system. Can I get the resources available? So those resources availability is also one of the important part. So I came up here with a niche idea where existing people are working. Can they ask the question again? The moment we talk about object recognition, so we want to find out what is the object in the image. And if we want to just make this answer, where is the object in this particular image? So what type of image is one question, and where is the object? That is also another question. So we have a clear input and clear output. So input is the image containing unknown objects, and output is position, label, etc., etc. And in case of detection, we are finding where is this object in the image. Input, again clear object, and position. Now these things are clear. With that intention we are working. Now just allow me to share the list of algorithms. Maybe that will be helpful for you to understand the next course of different persons lecture. And also if you are working into visions, I try to collect almost all the algorithms, and there will be a large set of algorithms. And these algorithms, not to discuss, only to mention that, okay, these are the possible solutions. Can we have a comparison? Where are the resources? And we can benchmark, okay, this algorithm is performing in this segment, and quantum computation or quantum introduction is making it better. I hope this type of intention, if we just carry with us, maybe within next few months or a year, we can find out a benchmark matters about the tradition versus quantum system. And maybe that's a new avenue for all of us who are interested in vision or image processing. So please allow me, these are known matters. I agree, these are known matters. I'll quickly go through to remind all of us so that we can have a nutshell of understanding. So this object detection is one of the very common matter for almost all of us. Now, different algorithms like two-step object detection, this if we accumulate, they are fast RCNN, faster RCNN, histogram orient, etc., etc. So what these are doing, they are finding the things being identified by our intention. Where is the object and what is the object? So these simple matters we are doing. Now, while we are doing, we have found out that image has been taken up into smaller chops. The same thing is done in quantum representation or qubit representation. So those who will be working like me, I'm a new person into quantum computing system, or even I don't know whether I'll be working or not. But first I have to be a clear idea that my system's resources, my purpose for those resources have to be a very closely tight bound, and there should be resources available. Now that question to be broken, that yes, we are finding a mapping and then we are going. So that's why with that intention, I tried to make this, that one-step object detection, these traditional algorithms, where I can chop the whole image in S by S grids. In quantum bits also, we can chop the, I have referred one page, one paper. There they have divided the whole input images in some 2n by 2n and 2 by 2 images, and they have just accumulated like our traditional neural network systems or propagation. So I just try to, I'm more curious that whatever our convolution systems and other systems are there, can they have a proper understanding with our existing system? So let me just quickly go through. Please don't mind. As these slides, if you require, I can share with you. So this accumulation, I tried to make to remind all of us the possible algorithms and their structural representation. So I'll just skip the slides. That how large number of algorithms are there. Only to name them. Even YOLO has a lot of latest versions. I have just taken few versions of it. This is to make an impression that we are rich in image processing, but are we rich in image intelligence? Here I want to take a break of 3 minutes, and break means I will love to have a discussion with you all. That definitely you have some kind of ideas in your mind. We can have a more discussion on CVs matters, and then we can continue. Otherwise, I'm talking almost for more than half an hour. So it's a time to have a break and we can make a discussion here. So I'll be very happy if some of you can give some feedback or discussion. Otherwise, I'll again continue. Please allow K. Praveen Kumar.
Yeah,
it was
I'll
really
just,
monotone.
yes, sure. I'll allow the mic. Yeah, Mr. Praveen Kumar, sir, you are allowed with a mic. Yes, Mr. Praveen Kumar, you can ask your question.
Okay, a rather question. If we can have some discussion also, it will also better. If you know, oh, please.
Yeah, sir. The point is actually I am working on this image processing, sir. So where I want to clearly understand that one. The CPU, normal computer, okay, so CPU, central processing unit, is going to be different in quantum computing. Is that the thing you wanted to be distinguished between the quantum computing and the regular computing? Because the CNNs and okay, so these algorithms are going to be common as of now, YOLOs and CNN or CNN, okay, so all are okay, going to extract the features using the several layers, deep learning models, and okay, they are going to extract the features. But this work is going to happen instead of the binary format or zeros and ones in the regular CPUs. It is going to be happen in a different way in quantum computers. Is this a point, sir? Actually, so we are going to study a computer organization subject or computer architecture subject in a quantum point of view in future.
Absolutely. Absolutely. That's why I just took this traditional system and deliberately, apparently, if I had been also the participant of such discussion, and if the presenter is only presenting traditional system, I deliberately took all the algorithms so that we all of us can ask this question to ourselves that is this existing system sufficient? Answer is no. The existing system to be mapped and things to be presented in a qubit systems, and the presentation should be different. The computation presentation is different. That's why the algorithms, whatever in traditionally we are doing, they are different from the supposed to be the different technologies and supposed to be different computational system. The intention here, your point is very right. That's why my very initial slide you have seen, there are 3 prerequisites to before we come to quantum image processing. Quantum image processing cannot be taken with the traditional system. It should have 3 prerequisites: quantum representation, quantum computing, and quantum information abstraction or retrieval, whatever the presentation is there, because we have to present it in that manner. Yes, I have a very limited knowledge about this conversion system yet. And the experts, whoever are corely working into those research, they might be knowing about it. So as I told you beginning, like you, my questions are and the answers are also similar. The mapping computation trade-offs. That means if I try to make the existing system and computational cost, it's high. It's definitely high. Presently also high. All the research paper they've addressed it is very high. Till works are going on. So that's why the thinking should be taken up as a new avenue. So I hope my intention of showing you the algorithms is fruitful. That means we first understand this is my existing system. So in course of our discussion, we can find out a mapping. Fine. Okay. Any feedback you want to give? Like how many of you are working exactly on quantum computing?
Sir, yes, we are hearing this word, sir, but we are unable to get that point actually. Okay, because quantum computer haven't seen. Only we are working with vision transformers and these things, and you are saying that one even vision transformers also inefficient to give some intelligence in the images. Okay, so we are expecting the better computational abilities or better computational
Absolutely.
systems and representation so that
Absolutely.
we can work
Absolutely.
out.
Absolutely. And that's the point of my next part of the slides. That's why I just called for a break. That means we will be starting right now on very interesting challenges. Some of my works I can share with you. That's why I just took let's have a discussion and move to the next one.
Sir,
Okay, let's
if
go to the.
possible, please give me the architecture of this quantum computing in a nutshell, sir. Actually, unable because we know the CPU, Central Processing Unit, ALU, or the arithmetic logic unit will be there, and so bits and we are going to convert it into raw bits, and it is going to process with the several bits and formatters. Okay. But is
Yes.
it going to be the same in the quantum computing also? Okay, so or is going to be separate names will be there, or so different
Okay.
operations will be there.
Okay.
Okay, that kind of.
I have 5, 6 papers with me. I'll share the links, and in my slide also those links are given. I'll directly, these papers are open papers. I can share with you, but these papers are also in a very limited format because those formats you cannot verify computational. You can just make a match in your own resources because they require a different format of computational part. But till you can have a consultation, I can just share those papers, whatever I have been came across. Okay.
Sir, one more
Let
last
us
question,
just
sir. This
please.
collab environment is there. Collab environment, they are giving the graphical units of the GPU systems, and these systems they are giving. So that way, similarly, onlinely, can anyone is providing us this quantum computing systems so that we can experiment or we can use those systems?
See, as of now, I don't have any access of such type of information on image matters. Some people, just I was searching for image matters, but as of now, I have not got such type of things. Like you can give some computational resources online, but till you can. I don't know whether you have discussed these matters with IIT Jodhpur, Devashish sir. You can ask the question to him also because they are having probably the resources on that. So
Yeah, thank you, sir. Thank you very much.
yeah. Okay. Let us continue our previous discussion. Okay. Now the question comes: what is image intelligence? So that image intelligence part requires a lot of computation power, and probably this is the area where we can come up with such type of computational thing, which is definitely a quantum computer science. Now, my slides are visible now.
Yes, sir, visible,
Hello?
sir.
Okay,
Yes, sir,
fine.
visible, sir.
So last point you can see, electro-optical and video and imagery, all these things can be taken up in a very good way for quantum computing part. So we were initially finding out that when my traditional system in a low cost can work, where are the challenges coming up? Definitely these challenges are coming up for a specific set of areas, like you can say real-time combat zone, then medical images, where we require very large image computation in a small time. So I just to show you some case studies. First, I'll show you a case study, and that is particularly this case study taken from military data and some aerial data. This definitely includes the geospatial data. And this particular case study is coming from, say, you want to deploy certain decision based on some information from drone. So this, you just take the case study. It has been taken from a drone, and a particular area, it has been searching a hospital. Now, as a traditional process, this drone have scanned the area. It is trying to find out where is the hospital. Now you see what are the markers of a hospital. So this is very difficult for any image processing system to find out the hospital in that area. Hospital is an label only, but all the buildings are almost equally likely. I have started with this example of hospital first, because in various hospitals, the roof is been marked with a plus symbol. Now, if you want to find out a school, now if you want to find out a certain building, how it is possible? So we require to assign certain kinds of real-time processing and some kind of situational processing. What is around it? Ambulance is there or not outside? A lot of information is required. So these tactical decisions require huge computation. In present condition, this computation to take a decision when it is flying is very difficult. So in many cases, it is done as an offline processing. So that is one area. So this high level processing is very, very difficult. Now, visual perception like 2D mapping, 3D scanning, etc. So here again, there are two examples given to you. Even as a human, none of us can identify the characteristics of the building. You just imagine that such type of things whenever come, it is difficult to abstract the information. So we have to go to the very detailed level of this qubit representation or even the pixelite information of the whole process. Traditional systems not efficient into doing that. These are challenging areas. Now, in these two images, the question is very simple. Can you identify playground and can you identify one church? You will find that as a human, you are searching it from one side to another side and trying to find out different semantic meanings. And those semantic meaning, and I'm sure all of you have found out one field. In the left-hand side, you are saying, sir, there is a field. Basically, it's not. It's not at all a field. So you can understand this is an internal periphery. It's not a playground or say public field. It's an internal periphery of a building. So this is very difficult when conflicting, confusing images are there. Now, as a human, how we can say it is not a playground? Because we are taking situational information. That is, what are the different angle information, and we are finding out, oh, that's been enclosed by certain building. So a lot of such things are coming up as one of the exploration and exploitation problem. Now, again, another case study. We want to find out some kind of estimation, like how many vegetations are there, how many special type of particular. So people readily say, sir, it's a GIS processing. So GIS processing softwares are there. These people are now doing this very nice way. Now try to find out the efficiency of those particular images. Then there are a lot of, that means ambiguous information. So there it requires a very interesting, that is information to process. Now coming to such type of thing, process dissemination. That means a combat team is moving through a certain desert area, or from the satellite images, some information ought to be given to them. But if such type of information is required to be validated, at least a close level, where is the validator? So validation requires a proper computation. So these case studies are very nicely said as a problem. Now these questions are coming as a vision AI. So this vision AI is again like quantum computing, a very interesting topic, and definitely it's now very popular. That means you are not only looking to the system, you are looking to the situational information. In our lab also, we are working presently on robot vision with situational awareness. That means like as we are participating virtually, some of you might be sitting in one environment and I'm in one environment, organizers in one environment. Think it about in the same hall. In same hall, even before you say something, the speaker or the organizers could sense how the audience is taking it up. Now here it is impossible to understand how the people are taking it up. That means the visual feedbacks are not coming. Even no kinds of you can say interaction feedback is coming. So that's why we have seen a lot of algorithms for different kinds of object detection, object recognition, etc. Now the question is turning into another way. How we can find out these meaningful informations and meaningful relation of those informations. So I will again go through some of the tools. I'm sure 100% of the tools are known by almost all the audience here. Till I have taken a deliberated effort so that I can discuss the tools and I can find out, is these tools ever talked about quantum computing? Is these tools will be performing better if we just think about a quantum computation matters? So that is the intention. So this image intelligence definitely comes with OpenCV. And I just try to make this pros and cons, TensorFlow, then CUDA, MATLAB, Keras, SimpleCV, and Microsoft Computer Vision. Obviously, this recognition of Amazon is one of the tools and important. Cloud Vision API, scikit images. Even if someone is new into the field, such type of assimilation tool is one art. So now I will present some of my works in our lab, and I'll definitely spread this thought process among you all, including myself, because I want to make myself motivated as well as a thought-breaking. That means how our systems can be converted into quantum computing system if it is beneficial for the computation purpose. We have a clear architecture. as I work with a lot of mobile robots, so we have a base station and primary processing unit. Generally, it's a high processing GPU-based systems and communication module. There's a Wi-Fi systems or point-to-point communication. There is a secondary processing unit, and it's an edge device, which is a low computation things. So field sensor don't directly come for base station. Field sensor first give the data to the primary, that means processing in the edge level. And field actuator also listen to it. Now, if the primary system, primary means in terms of field sensor, they are not able to understand, then it goes to the secondary level. Now, I just want to make a small childhood story. Let us consider we are in a nursery school environment. What happens? People have a limited knowledge. So parents have taught this is cockroach, this is a spider, and this is certain insect. Yes, they have learned it, supervised learning, and they have a proper leveling. Now, when they're in school, they found out a new insect. Now, this insect is never to them earlier. So what they will be doing? Just imagine, as we have grown up, then we can also observe these babies, or we can also think us as a baby, what exactly a human will do. So these human babies will definitely take it as a curious thing. And if we just take it from computation level of a baby, they will be having first curiosity. This is not available in my local knowledge-based system. So it will definitely communicate to the teacher or guardian, if in a linear process. Then the guardian will communicate, yes, what is its database, and found out it's butterfly. Communicate butterfly. And accordingly, the field actuators or actions. But if that is not a butterfly, but rather a very poisonous thing, and that is also not known to the base station. So what will happen? It will be considered as an exception to be handled in an unknown way, and it should not be explored. So if we apply the rule, things will be in a very rule-based system going on. But the question here changes. If you find out the communication disrupted in any way, then what would be the action of the secondary processing unit? So this secondary processing unit will be only working its local immediate data, whatever is available, because its computation ability is less. But my submission few minutes back, I said, say there is a large model being trained, and that model is available with the edge. Can it now take the decision of the model? Can it handle those model which has been trained in the large model? So we tried to make in our lab that whether the large models can be worked on the edge. In some cases, we are successful, and we tried to make smaller interaction devices. These interaction devices have been developed long back, but recently we are trying to make it a computationally very efficient matter. We have programmed Wiimote. Wiimote is a wireless gaming device. We try to take the gyro of that and to train the kids how to brush. Maybe it is having quantum computation far away, because there is no need of quantum computation at this moment. Now look to the whole scenario. The brushing behavior of small kids, generally we teach them early morning when they feel sleepy, or we try to teach them when they want to sleep at the night. Both the time these babies are feeling sleepy, they don't learn. It happened with both all of us. We never know that when we learn brushing. But exact movement of brush, if you want to teach them, we made a gamification and that interaction system. What is the problem here? We are using a high computation, high graphical system as a computer. Is it possible always to take a computer? No, because for just teaching a brushing in a gamification system, I cannot spend at least 40,000-50,000 computer there. We need a very cost-effective system with the proper visuals or etc. So where are the computation challenges? The computation challenges graphical information as well as interaction. The baby will never be interested if the baby is moving hand and the internal visuals are not moving. So that's why I am showing you this matter. The computational latency is very less. We try to take it up with the same architecture I shown you a few minutes back. The Wiimote is giving the gyroscopic data, and immediately it is sending the gyroscopic data to the computer, and we are trying to make it with a very less latency. But is it possible with an edge device? So that was the big challenge, and we tried to make it up with a computationally very fast small edge devices. It is possible, but graphical latency comes up into in a bad way. So see, that is one real life problem. These are some glimpses of our lab. As in my profile, as you have seen, we work with human-computer interaction and a lot of skeletal movement. Here, these robots are having small computers, very small computers inside them. Now, these small computers They cannot process larger data. So numbered data we try to process, and we try to find out the decisions to be taken to the actuators in a faster way. So computation is again the big challenge. Now, as Praveen Kumar has also asked that how this mapping to be done. Yes, it will require time. This mapping required time because I need to change the whole architecture and paradigm. These architectures are not meant for quantum computing system. Inside these particular robots, it's a traditional architecture computer. Now, quantum computation systems require the whole ecosystem to change. Then maybe my quantum processing, quantum application may be coming as a coherent system. Yes, it should not be a correct approach that we imagine everything to be quantum computer. No, quantum computing system has specific needs. That's why even if you search on the literatures, they are saying that certain applications, yes, certain applications to be taken in a very definite way. Okay. This particular slide, if you see, there is a balancing system of a robot. Now, what it is taking were crude gyro data, and that are being processed. Oh, I'm doing it to the traditional architecture, whatever is available with us. And in one of such FDPs, I was showing practically this, that when it is processing the data, it is processed in a level of 200 millisecond, 300 millisecond of whole throughput. That means you think, just for an experiment, I think we are all grown up, but we don't do funny experiments. Today, you try to stand in one leg the way the robot is doing. You will find you require a lot of balancing agilities. Think about the motor calculations, balance, and then processing. So that's physical, and this processing parts definitely challenging matters. And more important parts is unmanned ground vehicles. So the same architecture, what I told you, I personally work into this, and this is one of our developed system. When a high-speed vehicle moves on, so rather than making the vehicle move on, we taken a clip from one movie, and we try to find out in the movie what are the roadside sign available. Can it be processed by small computers like edge computers, not by traditional our laptop or GPU-based systems? So the problem statement is very clear. The high-speed vehicle, can they detect whatever the road sign around them and can find out the distance? So there are two components are there. One is identifying the sign and also the distance without radar, only by the visual perception. So definitely geometry applied here, and identification is a challenge. Now lighting condition, computation power, everything comes into. So again, a very clear CV, that means CV challenge. So these CV challenges is coming up here, situational awareness. That means what kind of sign it is, I have to identify in a high speed moving, so moving image directions. So we try to take up such smaller robots or computers. Inside this, there is a computation. This is a handmade robot. And the purpose of this robot, can it find out three-dimensional depth sensing? So as today I told at the very beginning, I'll share some of my experience of computational challenges with you. So this particular device, you can imagine it is having battery, it is having its processor, everything inside it, communication module, and it is having Intel RealSense 455D, a depth sensor, very powerful depth sensor. Now this depth sensor requires a lot of computation. It can identify around it what are the three-dimensional components and can take a decision that what is the path, clear or not. So try to understand the challenge here. The challenge here is not image processing at all, the computation. So this computation part, maybe this quantum computation comes with a smaller architecture, will be one area of work. These are the three-dimensional maps created by depth sensor. This is an example in our lab. Such type of 3D scanner is available, but take it up. These 3D scanners, what they can do? Perceive your surrounding, room mapping, or three-dimensional mapping of surroundings using LiDAR and etc., and find out a decision. Recently, we have tried to make an indoor exploration. Like, can the robot, whenever moving, that can identify what is the living objects and non-living objects around it. Now, these living and non-living objects require a lot of other situational awareness. A toy is there and a baby of human is there. How it can identify? So we use different kinds of simultaneous localization and mapping technique. Maybe it is a bit outskirt than the conventional image processing. So we fuse the technologies. So a few minutes back, you have seen depth sensor. Now you can see LiDAR. Now these LiDARs giving blind view. That means no RGB data. it is giving you a cross section, geometrical cross section. So this geometrical cross section is giving its input where there are objects, where there are some kind of path, and where there are some obstacles. So this here, if you see on the screen, the light is having no meaning because it is a blind sensor. It is deploying the laser sensors, laser cross sections, and finding a geometrical calculation. So in contrast to the previous one, depth sensing and cross section, they should be fused. Now, if I fuse, the computation requires large, and then it finds out, okay, what are the objects around, where I can find out edges, and how I can move around. It seems it's a common thing. Such type of things are available. Why we mix up this with quantum computing? Now, quantum computing here is coming up as a base station and a kind of remote station. So we fused both the sensor in advanced, some higher grade robot. Now it is having both the sensor, depth sensing as well as cross section. Now, when it is working, we are finding that things are working in a closed domain, in a known environment. If it is an unknown environment, it don't work. So these points are important for us to take a problem statement, and maybe that can give us a rise that how these systems can be computationally efficient. Now, if I take all these two examples apart and just find out how quantum computing can be mapped to that, a simple question comes that the computation system should be in a base station at this moment, and they can be work as an edge station. So that's why I presented the architecture to you, that quantum computing should not be thought of putting into the such type of edge devices. Rather, it should be a base station, and information can be sent, and we can make a low cost effective processing of the whole matter. Coming to the vision, you see what are the vision generated by the fusion. We are having a depth sensing, we are having a cross section, also IMU data. Altogether, the computer is seeing the surroundings, such type of cloud mapping. That means it can see that all these coordinate systems are spread up in three-dimensional manner. And what happens whenever this three-dimensional mapping is done, then it can take a proper path planning. It can move from one end to the other end, and then it can take a proper decision. So this is some small works. These are some of the references while working I just used, and abiding the time, I'm just concluding here. I don't feel that I'll be in a position to maybe answer, but rather I'll be trying to discuss the queries with you. So most welcome for some of the queries if you are having.
Okay, participants are requested to raise their hands in case they have the queries. We'll unmute you. Okay, sir, Praveen Kumar, sir, you can just ask a question.
Sir, are these robots are equipped with any kind of quantum computing, or the normal CPUs only have used in this one?
Not yet. You see, not for this robot. Even none of the robots around world, however I know, can be equipped with quantum systems or quantum computing. That's why the architecture is like this. These robots are edge computers with traditional computers. They are sending unknown data to a base station, which is hypothetically should be a quantum computer enabled system, which can process the data very fast. That's why I shown you the case study. Drone is scanning the field. The drone don't have that's computation power. It sends the image to the base station, and the base station takes the decision and send it back. So that may be the model. The same thing is done with the NASA, that is Jet Propulsion Lab. The photos they are making, they are also taking small snaps, that is combining them. The same thing happens with Hubble's telescope also. Roughly whatever been informations available over internet, how far we have seen that they take a smaller snaps, stitch them, and make a larger version detailed photographs. And that should be the way through which quantum computation can be used. Otherwise, you see, I cannot put the quantum computation on such small devices. It will be difficult. Maybe as of now, maybe in future things will come. It's a traditional computer, whatever I have shown you, my own experiences.
Yeah, you mean that one? Okay, so the way it is processing, actually taking the small parts and okay, so knitting up. Okay, so to make
exactly.
Yeah, this can be replaced with the quantum computing, so that we can do it better.
Yes.
Okay.
Just the idea is, see, qubits is working on a 2 by 2 pixels. in many of the papers are 2n by 2n pixels. So why not to make our problems divided into smaller parts and give it to the central computation system? They will be doing and giving back to us. So then you can find out faster processing.
Yes, sir. Right, sir. Thank you, sir.
Okay, any other participant want to ask any question? Please raise your hands. Okay, as we have no further queries, I think I will like to request Dr. Satyabrata Singha sir to propose the vote of thanks.
Good evening, everyone again. On behalf of all the participants and the organizing team, I would like to extend our heartfelt gratitude to Dr. Suman Dev for his insightful and engaging session on quantum image processing today. Dr. Suman Dev's deep knowledge and clear explanations of how quantum computing can be leveraged for image processing have provided us with a fresh perspective on this cutting-edge field. His ability to simplify complex topics and make them accessible has left us with much to reflect on as we delve deeper into the world of AI and quantum computing. We are also excited to announce that Dr. Sumanda will be with us again on the 5th day of the FDP, where he will be discussing quantum automated object detection. We eagerly look forward to that session and the further knowledge and insights he will share with us. Once again, thank you, Dr. Sumandev sir, for your valuable contribution today. We truly appreciate your time and effort, and we are grateful for the knowledge you have imparted to us. Thank you to all the participants for your attention and active involvement. We look forward to the next sessions tomorrow and hope you continue to enjoy the rest of the enriching FDP. Thank you all. Thank you, sir.
Thank you so much. From my side, I'll be really happy if you can just not question in the next session, you can also give some feedback also. Because you see, as I told you that we all are working into that is an unknown exploration and new avenues searching. So thank you for patient hearing and thank you the organizers for giving such a wonderful chance and hope all of us will be learning something from this FDP. Thank you. Good night.
Yeah, thank you, sir. Good night.
Thank you all the participants for attending today's session. Your attendance is already recorded in MS Teams, so there is no attendance link as such. And thank you for your time and thank you, Sumandev sir. Thank you once again for giving a nice presentation. Your presentation is always very informative and interesting. And all the participants, please join us tomorrow 6 p.m. again in the through the same link. Thank you.